Pagi Pak Bambang Iro.
Ya, sehat ya.
Assalamualaikum.
Salam. Ya.
Buati.
Assalamualaikum Pak Sigit, Pak Bambang, Pak Indra.
Gimana di Riau, hujan juga Pak Sigit?
Di Riau sudah mulai jarang hujan, Prof.
Oh gitu.
Mungkin udah seminggu, Prof.
Wah, udah mulai ini lagi dong, jaga-jaga juga.
Siap-siap, Prof, ke Riau.
Pak Sigit.
Attention please. Please turn off your microphone during the meeting. Thank you. The Honorable Indonesia National Coordinator, Professor Bambang Hero Saharjo, the Honorable Principal Investigator, Professor Marco Kren, the Honorable Secretary of Department of Silviculture, Dr. Erianto Indra Putra, our Honorable Speakers, Professor Keith Esselman, Professor Jenny Goldstein, Dr. Asmadi Saad, Dr. Sigit Sutikno, and Dr. Laura Graham, and also distinguished participants. Assalamualaikum warahmatullahi wabarakatuh. Good morning for Indonesian and Australian participants, and good evening for participants who join us from United States and Mexico. Welcome to the second international webinar, Lesson Learned and Finding from the Field. My name is Ati Dwi Nur Hayati, and I will be your Master of Ceremony today, Thursday, 10th of December, 2020. This event is held in cooperation between UMCES, NASA Tropical Peat Fire Research and Department of Silviculture, Faculty of Forestry and Environment, IPB University. First of all, I would like to thank everyone here for joining us to the second international webinar. I would like to read for today's agenda. The first agenda is welcoming speech and photo session. The second agenda is presentation and discussion. And the last agenda is closing. Excellencies, ladies and gentlemen, step on to the following agenda is welcoming speech. The first is welcoming speech from Prof. Bambang Hero Saharjo as Indonesia National Coordinator. To Prof. Bambang, please, time is yours.
Oke, thank you Bu Ati. Bapak Ibu yang saya hormati, Assalamualaikum warahmatullahi wabarakatuh. Selamat pagi and morning for our colleagues. We are happy now with you all. We are here for the second international webinar. Like I said a few days ago, that when we are talking about research, it's not just looking at for the papers of publication, but actually we need directly sound from the field. So that today we have several experts here. We have Professor Keith from UMCES, University of Maryland, and Professor Jenny from Cornell University. And then we have Dr. Asmadi from Universitas Jambi, Dr. Laura from BOS, and of course, Dr. Sigit Sutikno. And of course, we have many experts here from different countries. We have Graham, Adam, etc., the others one. We hope through these webinars, yes, at 8 we have, at 9, sorry, we have first seminar, and then the second one we have now sound directly from the field, and lastly, maybe the third, I think the last we will have another that also important regarding the emissions. So I hope you can enjoy. Hopefully through this way we can communicate and get the good results. And again, thank you very much for your attention. And now, Mark, is your turn. Thank you very much, Wati.
Thank you, Prof. Bambang. And the second speech will be delivered by Principal Investigator to Prof. Marco Kren. Please, time is yours.
Wasn't expecting a speech, but basically following on what Pak Bambang was saying, that we're very happy to get people here and participate in this ongoing project that we've had for upwards of 9 years now, and begin to see some of the products from all the work that we're doing, and hopefully be able to start applying some of this to both what we are planning to do, but hopefully what you are hoping to do. And so we're interested in not only presenting it, but getting any feedback that you may have. And so that's all I get to say.
Thank you, Mark.
Okay,
Yep.
thank you, Prof. Mark. Excellencies, ladies and gentlemen, before we start the presentation agenda, we would like to invite all participants to join the photo session for our documentation. So kindly please turn on the video for a moment. Robi, please take a photo. Mas Robi.
Oke Bu, ready. Oke, video aktif.
Mohon dibuka videonya Bapak Ibu.
Videonya on. Ready?
Oke, bahasa Inggrisnya pandai bahasa Inggris.
Oke, to slide. 1, 2, cheers. Okay, to slide. 1, 2, cheers. Oke, thank you. Bu Ati.
Oke, makasih Mas Robi. Well, ladies and gentlemen, now we will start our session on the second international webinar 2020 by theme The Lesson Learned and Findings from the Field. For the presentation session will be hand over to our moderator, Dr. Erianto Indra Putra. Pak Indra is Secretary of Department of Silviculture, Faculty of Forestry and Environment, IPB University. So Pak Indra, please, time is yours.
Okay, thank you, Bu Ati. Okay, thank you very much for the opportunity to lead this webinar. So thank you to all of the participants here for coming to this second webinar. We are happy to see you all here in the very happy smiley face. Yeah, I love your smiley face all. Thank you, Pak Kate, Pak Sigit, Bu Laura, Bu Jenny, and also Pak Asmadi. So now we will have 5 speakers here. So the top 1 speakers around the world, I think. Pak Kate for the model of the hydrology, Pak Sigit for his experience during his work for rewetting the peat, the burn peat, and every peat in the Riau, I think. Bu Laura will share also her experience during this NASA project. Bu Yani will talk mainly on the human activities on the tropical peatland, and also Pak Asmadi will give us his lesson learned while managing the hydrology in the Jambi province. So we will divide this session to the 2 main season. The first one will be talk from Kate and Pak Sigit, and after that we have discussions. We are sorry that Pak Sigit will leave on 10, ya Pak Sigit ya. On 10 will leave us because he has another task to be done today. And the second session will be from Bu Yeni, Bu Laura, and Pak Asmadi. Okay, I think we will start for the first session. First session will be delivered by Kate and Pak Sigit. The first one should be Kate. He is a professor in the UMCES. In the last year, in the last 2 years, I severally discussed a lot with Kate, but I'm sorry, Kate, I didn't catch your homework yet because a lot of tasks to be done here. Kate, time is yours.
Okay, thank you. Can everybody hear me okay? Yes, loud and clear, Keith.
Okay, awesome. I'm going to go ahead and share my screen if I can, and we'll see how this goes. How's that?
Yes, looks good.
Looks good.
Good.
Okay,
Excellent.
awesome.
Excellent.
Okay, well, thank you all again for joining me and tonight or this morning, whichever it is. Indra, thank you for your kind introduction, much appreciated. I want to start out and, well, obviously tell you what I'm going to be discussing tonight. I'm going to be talking about the process involved in the development and application of a hydrologic model of a tropical peatland. That's the title. It's just a little bit different from what Indra had, but I think it's basically close enough. And I'd like to start out with a disclaimer. And the first one is that while I'm a hydrologist, I'm actually a catchment hydrologist who's worked mostly on, not totally, but mostly on upland catchments here in the United States. I'm not a wetlands or a peatland hydrologist. I'm putting that right out there as a disclaimer. I have done some work on riparian floodplain wetlands here in the US, some early work we did in Virginia and the USA on that, but I've never worked on Indonesian peatlands or boreal bogs or the Everglades or anything like that. So this is, at age 64, it's kind of be interesting to think about myself being the new kid on the block. But this is really an area, exciting area of interest that I have, but I want to get that out there. I would like to just quickly acknowledge Mark, the NASA PI, of course, and Indra for really inviting me on board this long-term study of these incredibly interesting eco-hydrological systems. And that's what I'm going to call them tonight. Okay, so here's my outline. Here's what I'm going to try to get across to you. And I apologize if some of this is going to be new or old news or redundant of what you already know, but there really is a sort of a meaning to the madness here, if you will. I want to start out just briefly emphasizing the fact that peatlands are eco-hydrological systems. So I'm going to come back to that point, spend maybe 5 minutes on that topic. Then I'm going to just do a very brief, almost in passing review of extant peatland hydrological models, which is sort of the first step, I think, in thinking about using an actual model, is just reviewing what's out there and what you can beg, borrow, and steal, so to speak, from others. And then I'm going to talk again very briefly about the hydrological modeling process as it applies here, I think, to really any system, but particularly thinking about Indonesian peatlands in this example. And then I'm going to move into the last part of the webinar, which will be an example of how we would develop and apply a particular model of a particular type of wetland, in this case, a circular raised bog. So again, I'm not trying to use an illustration here from an Indonesian peatland. Rather, the example here is of a circular raised bog that we might find in the boreal zone of Sweden, for example. And I think you'll understand what I'm getting at as I develop this idea. Okay, so peatlands as eco-hydrological systems. I think when you look at the different kinds of ecosystems we have around the globe, you know, everything from upland to wetland systems on land and so forth, I think the thing you're going to find is that peatlands really are what I consider, at least, and I think many others do as well, the quintessential eco-hydrological system. They're the quintessential ecological system. And the reason for that is pretty simple. The main reason is that these systems represent an extraordinarily tight coupling of ecological, biogeochemical, and physical hydrological processes. That's really again, really the definition of an eco-hydrological system. So what are a couple examples of that? Well, the simplest example, I think, is that in the case of the peatland, the primary storage of water within that ecosystem is actually occurring within a porous medium that's formed exclusively from the decay of the vegetation growing in that ecosystem. So in other words, instead of some geological process, the transport of alluvial material and sedimentation and the subsequent formation of a soil on top of that material by a geological process, here we're dealing really just with biology. So that's kind of cool. So that's kind of the nice example. A second example of that would be that oxygen, of course, as a gas, as we know, is very sparingly soluble in water. Okay, there's really not, even at very cold water, there's very little oxygen within the water. So the process of saturating a peat dramatically reduces the rate of aerobic decomposition and thus allows for peat formation and development. Okay, so those are, again, two examples of this tight coupling that I mentioned. I don't think this second point is quite as critical for me. I think Mark touched on this a little bit in his address last night, namely that there's important positive feedbacks with huge implications for the global climate with regard to these systems. And then finally, I want to come back to another point, which I think is really based more on empiricism than anything. I don't know how many people here are gardeners or involved in agriculture. I'm kind of an amateur gardener here in Frostburg, and I tend to manipulate organic waste that I generate from the garden, leaves from trees and grass clippings and so on. And I use these materials in composting, basically accumulating organic material that I can return back to my garden as a way of preserving the tilth of the garden and the soil and so forth. And what I found is, just by complete empiricism, is that organic carbon is not tremendously thermodynamically stable in the presence of oxygen. And we know that because at the end of a summer, even in a relatively cool climate like Frostburg, Maryland, I've observed that maybe 2/3 of the mass of the material that I've accumulated and kept aerobic, by the way, throughout the summer by turning the compost pile, is essentially gone at the end of the summer. So with oxygen, we don't tend to accumulate very much organic matter. It happens very slowly, and then typically only very cold conditions. I'm thinking things like podzolic soils in New England and things like that. But even in the absence of fire, which Mark talked about a lot last night, and its critical importance in this process, we just don't accumulate organic carbon very quickly. So the second point, and Mark again touched on this a little bit last night, but I want to delve into it a little more detail. We have some empirical evidence that peatland drainage leads to peat shrinkage and subsidence, and we have known that at least since the 1600s. So this isn't like hot off the press news or anything like that. This is something we've known for literally centuries. And I want to just, again, spend a couple minutes on this. I don't know, I love reading books that involve sort of natural history and natural phenomena more from the layperson's perspective. And this is one that I happened on that I really love by an author by the name of Jeremy Pursglove, who wrote this back in 1988. It's called Taming the Flood. And it's all about how human beings, particularly in the United Kingdom, back through history, have gone about essentially trying to protect the land and citizens and so forth, the king in early days, from the vagaries of flooding, be it inland flooding from excess precipitation onto the land, or given the location of the United Kingdom up against the North Sea, as shown here, from coastal flooding. So going back, this is the area I'm going to be talking about briefly. So this is an area called the Fens here, which is about a 4,000 square kilometer portion of East Anglia in England, located to the northeast of London. This is a big wetlands complex. So this is an area of inland and coastal wetlands. And basically going back through time, surprisingly, it's a very rich a monetarily rich area. Has anybody visited this area, you'll notice the huge cathedrals and so forth constructed of stone, indicating this was a very wealthy area. The populace was very wealthy. A lot of agriculture went on here, sort of pastoral agriculture, despite the fact that it was primarily a wetland. So back about the 1600s, the Stuart kings, who were sort of in control of England at the time, think King Charles I, for example, he decided, well, he'd had enough of the fens. For whatever reason, and it's discussed in Purse Glove, he decided he was going to drain the fens, or at least begin that process. So he brought in a Dutchman actually, by the name of Cornelius Vermuyden, who came over and decided he had this plan to put in all these large canals and rivers and ditches and drains and so forth, and accelerate the drainage of water out of the fens into the North Sea. Okay, so that was the goal of this particular project. And you get an illustration here of the right of how extensive this drainage operation was going to be. Again, we're talking 1650 here or so. So this is all by hand and so on and so forth. So just thinking ahead a little bit about what this involved, of course, in the early days, in the middle of the 17th century, this involved pretty high-tech stuff, right? So this was a windmill-driven pump that still exists here at Wicken Fen, by the way. It's preserved, but Vermuyden was a big sponsor of using wind power as a way of driving pumps to get the water off the land and into the extensive ditch network that was created. Of course, that was turned out to be a big bust. So Vermuyden's efforts, much to the chagrin of the Stuart kings, found that the drainage efforts were a big disaster. Basically, all that happened was that the peat shrank, surprise, surprise, the land surface subsided, and much of the fens was left at a level below the level of the adjacent North Sea. So you see where we're going here.
Buat kamu konde-konde kayak peragaan, kayak orang bang.
The first winter storm would have been enough to cause a lot of problems here for the folks living in the fens. Okay, so true success in this example wasn't realized, and I have that in quotes, by the way. Taming of the flood wasn't realized until the 19th century.
Could somebody please turn off their microphone?
Somebody please mute. That's really annoying. Sorry.
Robbie, di smooth, di mute itu.
Thank you. As I said, success wasn't realized until the beginning of the use of coal-fired engines to actually generate steam and power, bigger, more powerful pumps. Here's the old engine along the River Ouse, and so on and so forth. So today, what do we consider success in the fens? We consider having to maintain 100 kilometers of coastal embankments, greater than 150 kilometers of river levees, 286 individual pump stations with multiple pumps, and maintenance of over 6,000 kilometers of water courses just to prevent inland and coastal flooding. So if that's your definition of true success, well, we should have a conversation about that at some point, because I don't think many of us would accept that as the definition of success. Okay, so I just want to illustrate this same process has been observed many places around the globe. Here in the US, for example, the Everglades in South Florida are another quintessential example of how drainage efforts, in this case well-intended to try to benefit the population and so forth, really went awry and led to outcomes that weren't considered totally desirable. Okay, so the second part of the talk, I want to talk about just our review of peatland hydrological models. So as I said, I was brought into this project, sort of started out working with Indra and Mark on some data from the Kalimantan peatland complexes. And gradually, I guess Mark again invited me to be part of the newest proposal to help apply some models to the Indonesian peatland systems. And the first step in that is just a review of what's out there vis-a-vis different models and modules. And that's what I'm showing here. And by the way, I don't have time to go into every one of these models by any means. You're probably thanking me for that. But at sort of at the crudest level, we can divide these models into steady state hydrological models and dynamic hydrological models. And there's really nice examples out there actually of both of these types of models. I'm going to end today talking about this first hydraulic groundwater mound model just because I'm most familiar with it, and also because it's the most parsimonious and simple model. So we'll come back to that in a few minutes. But I should mention one other thing here. These are the models that I could find in sort of a first pass of the literature that all had some substantial hydrological content, okay? So there's a whole bunch of ecological models of peat formation and peat development out there that really don't have hydrological content, okay? You following me? Some of these models actually have ecological content as well. They may be a hydrologic model within a peat development model, as in the case of Digibog, for example, is a nice one out there. Peat CLSM is similar to that. This is actually a NASA, what's the word? NASA implemented model, I suppose, part of CLSM. So there's a whole host of models here. And as I said, I don't have time to go into all of them, but these are the ones with appreciable content. And we have everything here from simple 2D models that are dynamic down to things that are much more higher dimensionality and totally dynamic, and might even involve simulating things like the thickness of the catatown, groundwater levels, storage of water as a function of time, and so on and so forth. So there's really a lot of material out here to draw on. Okay, so what do we want to do when we start the modeling process, be it a peatland or some other kind of system? And I always say the first step is to clearly state what you're trying to accomplish with the model. So in other words, what is your objective? As clear a statement as you can make of that objective, or objectives. So you can have multiple objectives that would be needed to be met here. And I should mention also that not all modeling is practically oriented. So for example, we heard a lot last night, not a lot, but we heard some last night. For example, Mark talked about the estimation of groundwater levels, the need to consider that feature in the fire process. He talked a little bit about peat moisture content and how we might represent that or estimate it over space and time. So these are some pretty practical kinds of things. Estimate change in physical peat properties. He mentioned bulk density, but I'm adding a new one, hydraulic conductivity tonight. Incorporate forcing by climate, for example, drought. Incorporate forcing by management action, the canalization and the canal blocking, and incorporate fire feedbacks. These are all very practical, I think, practical needs that we would have or objectives we might have in putting forth a particular hydrologic model for a peatland. But in addition to that, many applications we might have might be purely scientific, shall we say. For example, we might pick a model just so we can heuristically use the model to test hypotheses about how a particular system might be functioning. So just use it literally to sort of make observations of how that model actually works and whether it's able to either capture even crudely how a particular system is functioning. So that's our first objective. So I think the second objective, or the second question to be addressed, follows much from the objective that we've established. What type of hydrologic model do we need? And when we think about hydrologic models, I really think of there's about 5 classes of models that one might select from. We might have a purely empirical or statistical model, for example, a regression equation that just relates one model parameter to another might be enough for some particular applications. In other cases, we might be interested in using a lumped model, really a 1D model, if you will, just a conceptualization, really nothing more of how a particular system is functioning. Then we would get in, of course, into our physically based models, which I'm going to focus mostly on tonight. And those would be models where we might have at least some inclusion of things like the continuity equation, Darcy's law, things like that, that are pretty well established hydrologic methods and principles. We could even conceivably go with a stochastic model, one in which one or more variables within the model might be best represented stochastically or via a probability distribution of some form. It's another option. And then finally, I think this is going to be probably where we mostly will end up, is we're probably going to end up with a mixed model. And the one I always think about is a physically based / empirical model, where we might, for example, use something that includes continuity and Darcy's, but we might want to go out and collect empirical data on the system of interest to be able to characterize how that system actually functions. We need field data, empirical data, to make this model actually work for any kind of real system. What type of physically based model is needed? Another question we probably need to ask. And the first sort of breakout here is steady state versus dynamic. I already kind of showed you that we have both of those types to select from. And if we're thinking about a dynamic model, again, we're thinking about what state input and output variables are we going to need? What's the time step going to be? Do we need it hourly? Depending what we want to do with it, monthly? We could make that decision at some point down the road. The dimensionality of the physically based model is pretty important. 1D versus 2D versus a full 3D model. The spatial resolution. Okay, how well resolved in space does the model need to be able to meet our objective? And then finally, what about the parameterization? Do we want to seek parsimony, the simple model first, and then maybe evolve into a more complex model as needed? That would be my bent, as we'll see. Or do we want to start out with the complex model and then work our way back by maybe kicking out processes that we find are not tremendously important? And then a question always comes up here in parameterization: to what extent do we want to rely on and include the kinds of data we might be able to collect from the field to help us test, calibrate, and perhaps validate the model itself? So those are some other issues. Okay, so I'm looking at my watch here. I think I'm in okay shape. I think we might have started early from 8:30 because I'm only seeing 8:36. So I think we probably started a little bit early. Okay, so that'll give me time then to finish this. And I want to give this example. And again, I think the example will be clear once I've worked my way through it. But what I'm doing here is just trying to illustrate how we might go through this entire modeling process as it relates to these Indonesian peat bogs. What do we do to work our full way through the process of thinking about a model, identifying a model, perhaps developing the model, and ultimately applying it? What are those steps that are involved? That's what I want to look at. And I'm going to give an example for this because, again, it is a pretty well developed example in the literature of what has been done vis-a-vis circular raised bogs. And as I mentioned, these are typically found in the boreal zone, forming on relatively flat land that might have been flattened following the passage of a glacier that's left a layer of perhaps low permeability till on the landscape. Okay. What's been observed going all the way back, as you see here, to the 1930s to 1932, an ecologist by the name of Gronlund found just empirically, just going out and looking at these. Sometimes these are called ombrotrophic bogs, by the way. These are rain-fed bogs, circular raised bogs in the boreal zone. What Gronlund found was that when he looked at bogs of a particular diameter, and I apologize for this graphic, I should have had time to replot this, but these letters refer to different diameter bogs. They're circular, so the diameter ranging from 100 to 700 meters. And what he found when he looked at these different classes by diameter, he found these linear relationships between the square of the height of the bog in meters and the actual rainfall measured here in millimeters. Okay, so there's these nice, beautiful linear relationships. I wasn't there when he collected the data. I'm assuming these data are legit. They've been poured over by other folks, including Wickman in 1951, later Gore in 1983. They've looked over these data and they think everything is legit, but it's pretty cool, isn't it? So basically what you find is for the low or the very low diameter bogs, the smaller bogs, what he found was that the slope of this relationship is actually fairly shallow. And even with a rainfall of 1,000 millimeters, a meter per year, the bogs only get to maybe, well, this is the square of the height, so maybe of the order of, what would that be? 1.5 or so meters high. But it's only when you get up here to really fairly large diameter bogs, maybe 700 meters in diameter, that you see these really tall bogs, maybe reaching of the order of 4 or 5 meters of peat above the mineral surface. So this is kind of interesting, but it's just empirical data. So what do you do with something like this? Well, Wickham and then later Ingram took this information, this empirical information, and said, you know what, this really suggests to them a groundwater mound model. And I want to just show you what they thought about when they think about a groundwater mound model of a circular raised bog. Here's what they mean. So there's this area of land, and again, this is looking now in cross section. So if we're looking in plan view, this would be circular, correct? It's a circular bog, but in plan view, it looks like this sort of pseudo-cylindrical thing, okay? And the idea here, well, first of all, so here's the mineral soil, completely flat down here at the bottom and no slope, horizontal mineral soil at the bottom. And then growing on top of this is this sphagnum peat bog, okay? So what is this doing? How does this work physically? What's going on here? So I always like, when I teach my class about these, I always like to say, you know, if I had a sprinkling can here and I started sprinkling this desk that I'm working at here with water, and let's say it's perfectly horizontal desk, I'd really struggle to pond up water, wouldn't I? I'd end up with water all over the floor and the carpet would be wet and so on. I wouldn't be able to do this. I can't do this. So how can a bog do this? How can a bog pond up water to a significant elevation, maybe 4 or 5 meters high over glacial timescales? Well, the reason, of course, is that the peat itself is a porous material. It's a porous material with a limited permeability. So once you get water into that thing, again, where is the water? It's in between the pieces of the particles of peat, which are packed together and so on. They're decayed. The actual interstices of the peat may be fairly low. What do those interstices provide? Well, they provide a resistance to the movement of water out of the bog under the influence of gravity. We're not talking about sponge behavior here or capillarity or anything like that. We're talking about positive pore water pressure, okay? And we're talking about sort of a normal Darcian material that then is able to resist the horizontal movement of water out of the peat, the drainage of the peat. And that occurs because of the resistance, the limited permeability of that peat material. So what Wickham and Ingram proposed then was a simple model where these circular raised bogs are recharged by net precipitation, vertical net recharge from rain basically, or melted snow, less evapotranspiration, and then they discharge at the perimeter of the bog, okay? So in a steady state concept, okay, the net recharge has to be exactly balanced by the net discharge of groundwater at the perimeter of the bog, okay? That's just a statement of continuity, okay? At steady state, there's no change, there's no time involved here, as we'll see. So basically, we end up with a profile here that is governed by the need to balance the net recharge with the groundwater outflow. Okay, you following me? Okay, so that's the groundwater mound model. Now, it turns out that this model, or rather this raised bog problem, can actually be stated mathematically. So where did we go here? We went from an empirical set of data from Grönlund to an empirical conceptual model that put forth by Wickman rather, and now we're moving into a actual physical model or physically based model. And what these guys found, Wickman and later Ingram, was that this problem can be stated mathematically using the Poisson-Laplace equation, which then effectively treats the Peat system as an unconfined aquifer with uniform vertical recharge. And in polar coordinates, assuming again radial symmetry, which a lot of these bogs exemplify, we get equation 1, which is this Poisson-Laplace equation, where H is just the hydraulic head measured from the horizontal datum. N is that net vertical recharge of the bog. K is the saturated hydraulic conductivity of the peat. And remember what K is. K is really the coefficient of proportionality in Darcy's law, shown here. And then R, of course, is the distance from the center of the bog. Well, it turns out equation 1 is a second order linear PDE in H squared. And it turns out that the variable then, H of R, has the dimensions of length, as it should. Hydraulic head is measured in dimensions of length, while N and K are going to be dimensions of length per time, meters per day or meters per year, whatever. It turns out that we can get an exact solution of this equation by making assumptions about N, K, and the nature of the flow in the peat aquifer. And again, nothing involved here in time. So what is this? What are these assumptions like? Don't need to go through these too much, but just to mention, we're dealing with unconfined flow in a Darcian aquifer, no interaction of the bog with the underlying mineral soil. We're dealing with homogeneous isotropic hydraulic conductivity, constant uniform net accretion, or net recharge rather, steady horizontal groundwater flow with vertical equipotentials. That's the paradoxical Dupuy approximation that some of you probably remember. And then total neglect of an unsaturated zone, by the way. Remember I said this is just the water table, basically, here is at the bog surface. So again, I don't need to go through the whole solution technique. I'm just going to skip over it, except here to the last point, basically saying it's very easy to get a solution here for H is equal to a function of R. So basically, how does the water table or the hydraulic head vary as a function of the radius of the bog? So just quickly, I want to go through, again, some simulations just to illustrate what we end up with. So this was my initial condition for one of these circular raised bogs. This is one with a diameter, a radius of 1,000 meters, so a diameter of 2,000 meters. I assumed a net recharge of 1/4 meter per year and a hydraulic conductivity of 0.025 centimeters per second. And again, as I said, this is easy to do. You can do it in a spreadsheet. You get this elliptical shape of your circular raised bog where it peaks at the center of the bog at R equals 0, in this case around 4 meters. And you see it declines as we move out to the perimeter of the bog, at which point the hydraulic head is 0. Okay, so this is my initial condition. So what I kind of like about this is we can begin to use this model to deal with some of maybe the objectives we have to understand more about how this particular bog might respond to different kinds of perturbations. So the first one, and by the way, I always forget to mention this, I tell my class this, note the 100-fold vertical exaggeration here. This looks like a bog that would be like a church steeple by my diagram here. In reality, notice it's 100 times the variation. So if we actually drew this to scale, I couldn't even draw a marker thin enough to capture the variation in bog as a function, bog elevation as a function of distance along the radius. Okay, so the first one I wanted to look at because Mark raised this in his talk about the role of climate. and particularly was talking about El Nino and La Nina cycles and how differences in annual precipitation or rainfall might affect water levels within the bog. So what I did here was simulate a 50% reduction in the net recharge at the bog surface. And what you see happens is now instead of 0.25, we're down to 0.125 meters per year. And at the center, the bog water table drops by over a meter at steady state. And of course, that declines further as we move out to the perimeter of the bog. So what I'm illustrating here is this area between the initial case, the red line, and the black line is sort of the volume or the area, if you will, of peat that is effectively dewatered by the lowering of annual recharge. Okay, so you see it's a significant volume of peat now that's dewatered and now subject to aerobic decomposition using this particular model. I'm just showing these to illustrate, by the way. Don't hold me to any of these numbers. The next one I did was raise the perimeter water level. So down here at the perimeter of the bog, I raised the level 1 meter. And what was cool about this was, this is kind of the canal blocking idea. If you raise the level in the canal at the perimeter of the bog, what happens to the water table? Well, it actually goes up slightly, not dramatically, but it illustrates that we might be able to deal with the problem of declining, dewatering peat by taking some management action that's primarily at the margin of these raised bogs. And then finally, just quickly, the third perturbation or simulation I did here was looked at a 10% decrease in the hydraulic conductivity of the peat. This gets at something Mark said last night about, he was talking about changes in peat properties due to fire and oxidation and subsidence and so on. And he was talking about an increase in bulk density. I'm not so interested in bulk density. I'm interested in that, but I'm interested more in hydraulic conductivity because, again, that's what provides the resistance of this mound to subsidence, to this water table just collapsing. So what I found here, just decreasing the K by 10%, we see a modest but continuous increase in the water level in the bog as the hydraulic conductivity declines. So this suggests there may actually be a feedback. There could be a feedback in the sense as that peat gets denser and less permeable, this bog is going to drain less rapidly than it otherwise would. Okay, so those are the examples I'm giving just to illustrate sort of this whole modeling process all the way to the end, where we actually look at different scenarios and perturbations and try to make inferences about how particular systems might respond to these different scenarios. So finally, then quickly, the last step. So what are we doing? The next steps, it's the Kalimantan peatlands that Mark and Indra and others have studied for, I guess, closing in now on a decade or more, which we believe have the highest density of hydrological data that would support parameterization of a model, calibration, and testing. And I just give an example of the kinds of things that I think are available for this peatland complex: dip wells, slug test data, recession analysis, and then soil moisture time series via remote sensing. In terms of next steps, my bias is going to be to start with the simple model as I demonstrated here and add complexity as is needed, but not just for complexity's sake. And then finally, a practical step that we're trying to take as part of the new NASA funding, we need to hire a postdoc and quickly to continue the process of evaluating different models and modules and exploring modeling options for the future so we can achieve the objectives of the project. So please, if you know of people that would be amenable to working with us and qualified to take on this role, I hope you would let them know of the availability of this particular position right now. So that's it. And I guess I'm going to take questions at the end of the session, correct?
Yes, right.
Okay, thank you so much, Kate, for your brief talk and describe us how to develop the hydrological model and how to develop it in our site. I think there is an opportunity for you all if you want to try to work with Kate for developing this kind of model in the UMCES. The position is open, Kate.
Yeah. Yep.
Okay.
Yeah.
Just please keep your questions. We will have Pak Sigit for the second talks. And after that, we have a discussion. Pak Sigit, time is yours.
Okay, Pak Indra, thank you very much for the opportunity. Is my slide appear in your present? Okay. Okay. I will. So the topic of my presentation today is about the water management for hydrological restoration and peat and fire prevention in tropical peatland. So I'm Sigit Sutikno from University of Riau. The photo background here is our site in Tanjung Leban. So originally in 2008, this area was fire and totally damaged by the fire. So after that, the local community together with University of Riau tried to save the peatland for the peat restoration. And this photo I took in the beginning of this year. Now the condition is very good environment, and we think that this area is kind of on the track peatland restoration. I will talk about this in depth in our next presentation. So this is just for the introduction. We understand that how the peatland degradation process here from the original and land conversion and making the canal and then the subsidence, and this is the end stage. So we together with our colleagues from Yamaguchi University try to capture the now condition in the peatland in Rio especially, and maybe also in Indonesia. So this is the original condition. We have found the tropical peat swamp forest here, and after that the forest have been converted to the plantation and make the canals, so the peat become dry and very vulnerable to fire and also abrasion, especially in the island pits. So in Rio we found many island pits that very huge abrasion disaster. So now the condition here, so we can understand that the degradation process surely happen now in the tropical peatland in Rio and also maybe in Indonesia. So how should we save this condition? So this is the restoration activity. So the basic action of our restoration is how to keep the peat always wet. So because of the Indonesian is tropical country, that the availability of water is not well distributed on the time and spatially. So water management is important aspect for hydrological restoration. because of the water not available along the years. So we have to research site for the research action for the hydrological restoration in Rio. So as I said before, that we have found many island peat in Rio. So this is a Rupat Island that more than 50% is a peat. This is a Bengales Island that up to 90% is covered by peat, and Padang Island, Tebing Tinggi Island, and Rangsang Island. So this island peats very vulnerable, not only fire, but also the coastal abrasion, because of the peat properties is very light than the sand material or soil material. So in first site we call Tanjung Leban site, that located in the Tanjung Leban village. We have 36 deep well and 3 subsidence pool. Also in island pit in Pulau Tebing Tinggi peatland restoration unit in Sungai Tohor, we have 66 deep well. We also monitor the vegetation growth. So this is the more detailed condition. So we have 3 transect in the Tanjung Leban site, that totally 36 deep well. That we set we monitor the water level fluctuation. Now is the 3rd year for the beginning research. So we also have construct the canal block here, this area, so we can understand the impact of the canal block on the groundwater level rise. Also in Sungai Tohor site, we have 6 transect, that totally 66 deep well. So the land is covered with sago plantation here, and this is the main canal like this. We have many canal block here. So this site was never burned, but this area is very frequent burn before 2015. So we try to analyze the water level fluctuation. This is in the Sungai Tohor site. So we want to understand the impact of canal blocking. This is a relating effort for groundwater level fluctuation. So this is the fluctuation in the water level in the canal, and this is in the peatland. So when the canal is blocked, the water rise, and also in the peatland also has rise. But in some area that's about the 500 meter, the fluctuation is not impacted by the blocking canal. So if we try to make the graphic to understand the increase of groundwater level to the distance to the canal. So this is the rise of groundwater level, and this is the distance to the canal. So we can understand from this side the impact of the blocking canal could rise the 160 meter on the side. This is not so far because the topographic condition more than 170 is too high, so the water penetration cannot reach more than 170 meters. And in the Tanjung Leban side, we have many deep well, and we can understand the fluctuation of water table This is before blocking canal, and this is after blocking canal. So after blocking canal, the water level in the canal and also in the peatland rise significantly here. So we can understand the impact of the increase of groundwater level to the canal from here. So this is the fluctuation because of the rain, but this is because of the blocking canal. In this site, we found that the radius of rewetting impact about 270 meters. This is our finding from monitoring the water table in the Tanjung Leban village, and this finding also was included on the BRJ 5-year reports in this month maybe. And this is the cross-section of the water level fluctuation, that water level fluctuation could reach the radius about 270 meters like this. So we want to understand also the groundwater fluctuation before and after canal blocking spatially. So we make a map based on the water level fluctuation in the Tanjung Leban site. So this is the map before canal blocking, and this is a map of groundwater level after canal blocking. So we can understand that before the canal blocking, the water level is not so high, but after blocking, the water table is kept in the high condition like this. Also in this period in Rio, we understand that this is the first of the the first period of dry season. So usually there is a fire in this area. In this period, we pick up the area surrounding this site. For example, in Rupat site, in this period already have burned. This is the red site. This is peatland fire in this period. Also in the Bengalis Island and Rasang Island. So from this finding, we understand that GWL remain high, and there were no fire while fire have occurred in the other place at the same time. Also, we want to understand the impact of the canal blocking on sago plantation. This is in Sungai Tohor site. So we have captured the condition of the sago plantation here. This is the west side and this is east side. We can understand that this condition, this sago plantation have a good tree, have a good health for the growth of the sago, and also the local people also said that this is in this area the sago plantation have high productivity. From our monitoring of groundwater level fluctuation here, we can understand that in this area is higher than this area. It means that groundwater levels in sago plantation have a good impact on the sago growth. So this area is better than in this area. So finding from this exercise, we can understand that high groundwater level is a good for sago plantation, which is in line with the peatland restoration effort, because the peatland restoration is try to keep the water level in the high condition. This finding also was included in the BRJ 5-year report for this months maybe. So this is also the other capture for the aerial photo. We can understand that in ICAPS that there is sago crop bed this area is better than in this area. So we also try to get the lesson learned from the small scale water management in this area. So this is the picture in our first slide. And so this area is in this position. So there is a canal here and canal here. We make a blocking canal here and here. So this canal become a long storage. So with this system, this area is keep in always wet condition. This area. So the local people also make revegetation with the original tropical peatland trees like jelutong and so on. So this is the timeline of the historical site area here. So originally in 2008, the area was totally damaged by peat fire. So and then the area is about not so big, but it's about 3 hectares. But we understand that this area, we think that on the track peatland restoration effort in this site. So local people try to plan the local peatland, so like Jelutong. So in 2011, we start with the plantation, and this is the condition year by year, and we make the canal blocking for keep this area always wet. And now the condition like this, and very good environments. And now we are constructing we call the research station for peatland restoration. So this building like this will be our research station with and the building for communicate with the local people, how to get the lesson learned from this activity. And now we are trying to upscaling this area, become a wider area, especially in Tanjung Leban village. And if we can upscaling also this area on the other side, maybe it's very good for the peatland management and peatland restoration. So in the last slide, I would like to make a conclusion and recommendation. So the rewetting activity by canal blocking has a significant impact on the increase of groundwater level, so that the risk of peat fire can be minimized. The radius impact of canal blocking is up to 270 meters from the canal. Of course, the impact can be larger or smaller, depend on the hydrotopography condition and the characteristic of a peat. Sago plantation is very good on the peatland with the high groundwater level. This is inland with the peatland restoration effort, which maintain a high groundwater level to keep the peat wet. Peatland restoration effort is not instant process, so we can understand from this. Start from 2011 and 2009, it take about at least 9 years. If we intensively manage the water table and also the area. So we understand that peatland restoration effort is not an instant process. It took a long time to get the impact with the continuous effort or maintenance and also improvement year by year. I think that's all my presentation today, Pak Indra. Thank you very much.
Okay, thank you, Pak Sigit. Now we already have the talk from the two speakers. From Kate, we can learn how to develop the hydrological model, and he is suggesting us to try the Wickham Ingram model. I think some of you have a question on these models. You can ask directly or using the chat room. And from Pak Sigit, we can have the very great result for the radius of impact ya Pak Sigit ya for 270 meters. Okay, I think we already have the question here. This one is for Pak Kate. Pak Kate, this is a question for you. What is the best hydrological model for peatland in Kalimantan and Sumatra? And how peatland type and peatland depth influence the Ingram hydrological models? Pak Kate?
Yeah, okay, so I'll take the second part of that first. So how does peatland type and peatland depth influence the Ingram hydrologic model? I think I wouldn't say it quite like that. I would say more that within the model, what the model does is establishes through the theory really that I developed and talked about the relationship between these various geomorphic properties, depth and size and so forth, diameter, and the hydrologic variables, namely the permeability of the material or the hydraulic conductivity, and certainly the net recharge of the system. So that's how that works. It's really not how one affects the model. It's really what the model allows, which is to essentially integrate the hydrologic function with the size and characteristic properties. And then the first part, what's the best model? I always shy away from people asking me questions about what is the best hydrologic model, because as I was kind of trying to imply or kind of state, really the best hydrologic model is the one that turns out to be the most useful in addressing the specific questions we have vis-a-vis the modeling. So for example, if we're interested in understanding the dynamics of a water table during the course of a dry season and how that water table may recharge during the wet season and so forth, we would certainly want to think about having and applying a dynamic model, because we're going to be interested in how things are varying over time and maybe over both space and time. So we have to, I just don't think we can say. It really goes back to the question we're trying to answer, what our objective of a specific model is.
Okay, thank you, Pak Kate, for the questions. And there is another question from Bu Imas again for Professor Kate. I image the illustration of Ingram model as a cylinder containing water in the curve of diameter to height. Is it true or not that the objective of Ingram model is to obtain the optimal value of the diameter and the height that give maximum volume of cylinder when other parameters are constant?
Sure. So the basic idea here is that we're trying to find what that function is, h as a function of r, for the particular parameters that we've applied in the model. And so there really were only two. There was the hydraulic conductivity and the net annual recharge to the system. So we get the water table, if you will, or the hydraulic head as a function of r for that cylinder, as you say. And then sort of the next step implicitly is to draw the assumption that we're unlikely to have more peat above the water table, because again, that part of the system is going to be aerobic and it's going to be decomposing over time pretty quickly. So we have a real limit to growth here that is determined by the different hydraulic parameters that I described in that model, if you believe that's a reasonable model of these circular bogs.
Okay.
Good questions. Thanks.
Okay. Thank you, Pak Sigit. Bu Imas, how about the answer from Prof. Kate? Do you have any other question for Pak Kate? Or do you want to make any comment?
It's enough. Thank you very much, Prof. Kate, for the answer. Yes.
Okay. Thank you.
Thank you.
And okay, thank you very much, and Pak Kate. So there is a question from Pak Bambang to Pak Sigit. Pak Sigit, how we measure and ensure that rewetting is there?
Okay, thank you, Prof. Bambang, for the question. So how we measure? Of course, we measure with deep well. So we have 36 deep well in Tanjung Leban and 66 in Sungai Tohor. So we measure using water logger and also manually. So some point we have the water logger, and as many point we measure manually. So to understand the rewetting is there, of course we compare the intervention rewetting using canal block. How is the impact after, before and after? Before rewetting, how is the water table, and after rewetting, how is the water table? If there is the increased water table, it means we can understand that this area is impacted by the rewetting efforts. That's all, Pak Indra.
Pak Bambang, do you have any comment on the answer from Pak Sigit?
Yeah, I have a small one because everybody talking about rewetting, but the public asking, are there really rewetting there? Because we do not only check only the groundwater level at certain period, but we also would like to know the impact of it. So from there, we then claim that, okay, now we have already our peatland already rewetted. Because I already went there to the Bengkalis. Finally we found it's not rewetting, but reloading, because the area is flooding, it's not rewetting. So sometimes, it's hard to make differentiation which one is the true one with the others. Even I already already arrived in that site, because on the other canal, I saw the area is flooding. It's not rewetting anymore, but loaded. This is the question emerged. And also maybe audience here would like to know how then we come to the conclusion, like Pak Sigit mentioned, okay, rewetted is already there. For instance, maybe one of these, the parameter is, for instance, like biomass, and then we know that year by year something is going in there, and then we claim, okay, this impact of the wetting could be directly shown from this biomass, etc. Actually, this is what I asked, and also Pak Sigit have a good answer on it. But if you have another comment, please, Pak Sigit. Thank you.
Yeah.
Okay.
Okay. Thank you, Pak Bambang. Yeah. In the field, we can find so many kind of canal block, so many type of canal block. So sometimes people make canal block is not flexible. It's not flexible. I mean, Indonesia in the rainy season we have the very big rain sometimes, and also in dry season we don't have anymore. In 1 month there is no rain, so and with the high fluctuation of water availability, we should make the flexible canal block. It means that in the dry season, we close totally. So I mean with the gate system, with a gate system. So in the rainy season, we open the gate so to avoid the flooding. So this is the special characteristic for the peatland with this condition. So we recommend with the flexible canal block model. Set all, Pak Bambang.
Okay, thank you, Pak Sigit and Pak Bambang. I think it's still challenging for us how to provide to the public that this canal blocking is very useful for us. And I think this research will try to answer this, Pak Bambang and Pak Sigit. Okay, the other one is from Pak Graham. I think Pak Graham want to ask something to Kate directly. Please, Pak Graham. Graham, are you there?
Thanks a lot, Keith, for the very enlightening talk. One of the phenomena that we constantly see in these peatlands, particularly in Indonesia, in the first couple of years after the forests are cleared and the canals are dug, we get this very sharp decrease in the elevation of the peat, and then of course the subsidence then reduces quite dramatically, and we get to a couple of centimeters per year although the drains are in and the water runs off. So is this really a function of this, you're talking about this hydraulic conductivity, does that mean that then decreases, so the peat or the hydraulic conductivity then decreases, and that causes this peat then to the subsidence to become reduced compared with what it was in the uncleared state and undrained state?
Yeah, I think there could actually be several things going on there. One, and again, I'm not the world's expert on the structure of this, the peatlands here and the particular variation in hydraulic conductivity with depth, but I would assume that the upper peat would be more of the sort of the acrotelmic type that you see in boreal wetlands, and then as you go down, you're into the more catatelmic kind of peat, which is denser, maybe a factor of 5 denser than the acrotelm, and would have an equivalently much lower hydraulic conductivity. So part of what might be going on is you're just losing that surface peat, which is that less decomposed peat, which just happens to have the higher hydraulic conductivity. I'm thinking that's probably a big part of the explanation. And then the second part, of course, is what you said: as the peat is aerating and compacting, the surface is basically just subsiding. And with that, the same kind of phenomenon is probably going on. So
yeah,
that's speculation, though. Just
sure.
What I know.
That's quite interesting. Yeah. Okay. Thanks very much for that.
You bet.
Okay, thank you, Kate and Graham. The other question is from Laura. This one I think is for both of you, Pak Sigit and Kate. The impact of the canal blocking is great and interesting to see, but we are still only seeing in the short term when season and interannual variation is still occurring. How would you, Pak Sigit and Pak Kate, approach future analysis to account for these variables? Or is a long-term monitoring is the best solution? Maybe about Kate first.
Yeah, I would never turn down an opportunity to do long-term monitoring. as a way of establishing the different relationships and processes that are ongoing. So I would put a 4-star next to the long-term monitoring aspect of the study. But as the previous speaker said, long-term could be a pretty long-term project. I mean, some of us may not live long enough to see the kind of results that, you know, we'd like to be able to complete a particular project, if you know what I'm getting at. So we do have needs to think about other things that we might be able to do more quickly, I think, to determine whether these actions are being effective. I liked what the previous speaker showed in terms of having devices for measuring surface subsidence and rewetting of the peat and so forth. I think I don't see as many, I don't know we have as many measurements of peat moisture content, bulk density, hydraulic conductivity, those kinds of measurements. I don't see maps of that kind of thing going on. So we have a lot of water measurements, but in addition to that, I'd like to see sort of what Graham was asking about. What are the changes in peat structure that are accompanying these processes, and whether we can see that spatially in our data sets. But to get that, we have to go measure.
Okay, thank you, Kit. Pak Sigit, you want?
Yes, I think the continuous monitoring is very important for understand the hydrological tropical peatland, because the process we can understand year by year, and with the field data is a very good information for the hydrological modeling. So actually also now we are developing the hydrological model to understand the water balance in the peatland, but maybe next time I will present about this in the next opportunity. So we found that the difficulty in peatland is how to predict the water discharge in the canal. So now this year we start to measure the water discharge in canal, and we compare with our simulation, and fortunately it's a good correlation between our prediction and with our measurement. So it means that the hydrologic model is a good correlation with the field measurement. By using the hydrologic model, we can simulate the many scenario of management. For example, with canal blocking, how is the impact on the amount of the discharge and so on? How is the impact on the water table fluctuation and so on? So it is very good for the maybe a decision maker before make a decision is simulated by the model to find the best scenario. So the best scenario will be recommend for the decision makers. So continuous monitoring and hydrologic modeling is the important thing for the hydrologic study in the peatland. Yes, Pak Indra.
Okay, thank you, Pak Sigit and Kate, for the answer. So, Laura, do you have any comment on this answer?
No, thank you, Keith and Sigurd. It's interesting. I think it's always that balance, because the long-term data monitoring is, of course, the simplest and potentially the best solution with all the variabilities. But equally, you know, we need to as Indra said, we need to convince people now. Not everyone has budget or facility to do the long-term monitoring. So it would be good, and it's an interesting point that Keith raised, that perhaps not just, although it's instinctive to use because we're canal blocking, so we consider only the hydrology or the water table aspects, but actually because the water and the peat are so interlinked, maybe we should be focusing on a short term. We might see less impact with season or interannual variation with the peat aspects rather than the water table aspects. So that might be a good starting point for short-term monitoring of the benefits of canal blocking, which we're not doing as much at the moment. So it's a good point to note. Thank you.
Okay, thank you, Laura. So we are moving to another question. This is from Mark to Pak Sigit. Pak Sigit, is the 270 meter distance is the same year after year? I'm wondering if the structure of the peat might change over time after rewetting.
Yes, this is still 1 year monitoring. So I think the question for Mark make inspiration for us to continue the monitoring, and how is the impact on the next year. Is it the same condition or not? We should investigate it more for the next monitoring. Thank you.
Yeah, that could interact with what Keith is talking there too, because we know that it changes structure when it's drained, but I'm not certain we know how well or how long it takes to recover, or what degree it does recover. But yeah, so hopefully keep the good work up and keep collecting that data, so we'll find out. Because I don't know of any other data that'll show that for us.
Okay, Mark, thank you. So we are still working on this data, Mark. So for Riau, we have 2 sites that Pak Sigit already acknowledged, that this is in the Tanjung Leban and Sungai Tohor. So we will try to explore this data and let you know the result then. Okay, thank you, Pak Sigit and Mark. So we are moving to a question from Pak Acep. I think this one is for both of you, Kate and Pak Sigit. When we block the canal, according to your data, it produces small fluctuation of the groundwater level. What if canal blocking is done in open areas or without vegetation? Is there impact for 1 year? Yeah, I think it's quite similar with the question from Mark. Pak Sigit, do you want to clarify this?
Yeah, I think similar question. Yeah, of course. Yeah, maybe 1 year the structure will be changed. Maybe the vegetation, also the subsidence, the parameter like hydraulic conductivity is maybe will be changed, and this is very important parameter for the penetration of intrusion of water to the land because of canal blocking. I think yes, we should continue for the next monitoring, and we should understand how is the impact for the canal blocking. Thank you.
Okay, thank you, Pak Sigit. Kate, from your point of view, do you have any idea of this canal blocking? I think this canal blocking is still very important to our peatlands, but I think based on your point of view, what is the best canal blocking that implement to prevent our peatland area?
I'm not completely familiar. I'm just looking at what the previous speaker showed in the way of pictures of the kinds of techniques that are being used there. So I don't know what all the different technical options might be that you might use. I think he basically talked about using the blocking in one season versus another, opening things up during the wet season and so forth. So there's a whole the different operations, obviously, that probably be governed by the hydroclimatology of the site and maybe other things that are important. You know, I guess the one thing that comes to mind here that I really want to learn more about, I guess, is once you get subsidence of these systems and, you know, the peat's compacted and so on, doesn't the reflooding then just produce areas of open water rather than nice uniform peat saturation? I guess it would depend how high you would control the water level in the system, but I would assume that this subsidence isn't occurring perfectly uniformly. So you might have undulations and so forth. It might actually be areas of open water rather than saturated peat. So I guess that's a question I have, whether this is going to be a really useful technique over the long haul. I don't know if that's a good question or not.
Okay, thank you, Keith.
Keith, I think it's an excellent question, and I've just put up a comment in the chat. And I think one of the issues that we've faced in Indonesia for a long time, when the canals were first talked about, which was to be blocked, which was back in 2006 or 7, I think. And that was initiated by Wetlands International and the current Vice Minister of Forestry, by the way. And they were focusing on just building dams, similar to the ones that you saw in Dr. Siget's presentation. And I think we've moved on from that now, realizing that these dams are quite expensive. They don't actually function the way we'd like them to do. They get damaged. And so where we're focusing more now is to actually blocking the canals and filling them in as a way of getting rid of the canal, not just putting dams into those structures. So I think that's still a debate, and BRG is moving more towards this actual blocking of the canals and filling them in, rather than the old technique of just putting dams, which we know don't sort of work in the long term. So I think that's an ongoing discussion that we should have, and I think it's quite an important one.
Okay, thank you, Pak Graham. The very interesting discussion on this canal blocking. But we have another question. I'm not sure this one is already answered or not. Dear Pak Sigit, I see this one is from Pak Mulyadi. Dear Pak Sigit, I see in hydrology in Tanjung Leban and Sepahak connected with canal from acacia plantation. Did you ever get in touch with private sector for water management? Because in rainy season, I hear from the community it is flooded in that area because company discharge water from their concession. This one is already answered by Pak Arif. My help Pak Sigit, of course, on our project, we have good communication with the company where the managing the water table hand in hand with them. So I think it still need clarification from Pak Sigit.
Okay, thank you, Pak Indra. So thank you for the question, Pak Mulyadi. So in 2017, we have a hydrological study in the Bukit Batu Cagar Biosphere, and in that study, we recommend for the water sharing because the concession area in the upstream area and the local community in downstream area. So sometimes in the rainy season, the concession open the gate and flooding in the community. And in the dry season, the concession area close the gate and the drying in the community area. So we recommend in our last study, we should have the water sharing discussion and management with the upstream and downstream area. So the recommendation have been implemented on start from 2019, I think, facilitated by GPP project coordinating by Pak Arif already make a answer here. So start from 2019, we have discussion intensively between the concession hydrologists and community. So, for example, we have make the WA group to discuss how to manage the water, through the canal. So, for example, a local community said that, oh, in our area now water table is low, and then the concession open the gate, and similar for the in the rainy season. So this communication have already start since 2018. Pak Arif said in the chat, and until now condition. So this is maybe to be one of the best practice how to manage the water in the one landscape area, not partially. Community itself and the concession should be discussed together, and how to manage water in the peatland and appropriately. Thank you, Pak Arif. Pak Arif and Pak Indra.
Okay, thank you so much, Pak Sigit. We are very glad here that we have such a very nice discussion on the peat water management. So there is some point that can take a note that the water management in the peatland is very important to prevent the peatland in Indonesia from the fires, and from case such like the possibility of using this WCAM to modeling the hydrology of peatland in Indonesia. And also we can have here that we actually don't need the long-term monitoring to develop the model, but we still need some sort like appropriate variables to develop the models. And also however, the continuous monitoring is still important as long as we still have a budget and the resources for that. Okay, thank you very much for this discussion. Thank you for the presentation, discussion, Pak Kate, and also Pak Sigit. The time is limiting us, but we will be very happy if you still have any question, you can directly ask to Pak Sigit or Pak Kate, or you can deliver the question to this to the committee, then we can deliver the questions to them. Okay, thank you for the first session. I think we will move to the second session. Thank you, Pak Kate and Pak Sigit. I hope you are still here, but if you have any other agenda, I think you may leave, but truly we are still hoping that you are still here with us. Okay, please give a big applause for Pak Sigit and Pak Kate. Okay, thank you so much. So we are moving to the second session. So we will have 3 speakers here from Bu Jenny. Bu Jenny looks that Bu Jenny is already familiar with Bahasa, I think, because he has a lot of field work in Indonesia and a lot of papers regarding the role of human activities in tropical peatlands in Indonesia. Okay, time is yours, Bu Jenny.
Terima kasih Pak Indra.
Selamat pagi semuanya di Indonesia. Hi everyone, it's great to be here. Thanks for the invitation to Indra and Mark. So today I'll be talking about the role of human activities in tropical peatland fires. Everything I'm presenting today comes from a recently published paper that was based on some of the NASA-funded research that has been led by Mark. And I'm very pleased to say that I think a majority of the authors on the paper are with us today. So I won't be talking about everything in the paper. It was quite an interdisciplinary team. So I'm happy to answer questions on things that I've sort of glossed over, and I know some of the other authors can do so as well. So I just wanted to call your attention to the stakes that are really, I think, embedded in this webinar series. I know there's been really great presentations on the technical dimensions of peat fires and of water management in peatlands, but what's really at stake here is these massive peat fires that periodically erupt and affect millions of people across Southeast Asia, as I'm sure everyone here on this webinar is familiar with. The 2015 fires, which were the most severe in the last couple of years, alone are expected to contribute to 100,000 early deaths from smoke exposure, particularly affecting children and the elderly. Of course, the carbon emissions toll on global climate change is enormous. The billions of dollars lost to Indonesia's economy, as well as other countries in Southeast Asia, is also enormous. Again, this is, I know, familiar to everybody here, but just a sort of reminder of, I think, what's at stake in a lot of this work is really this, right? This severe air quality and the toll on human health, particularly. So what I'll be talking about today is really the driving question of the paper that we've published in the Singapore Journal of Tropical Geography, which is looking at the role of human activities in these peat fires. And we started with this question of under what conditions does the surface fire transition into a subsurface peat fire? This is drawing significantly on the work that Mark has done and Laura as well. And I entered the project as a social scientist a couple of years after it started to try to understand how human activities really affect this fire transition. So we started with this premise that there is a difference between surface fire that spreads across the peatlands in these degraded areas and the fire that transitions into the subsurface or the peat layer, which is much more noxious for human health when the peat layer burns, as well as contributes a significant amount of the carbon emissions into the atmosphere. So we really wanted a more nuanced understanding of how these peat fires work. And the one kind of, I guess, overall observation that I had made with other social scientists on the team was that, most of the human dimensions are often attributed to slash and burn agriculture. This is something that, has gotten repeated by policymakers in Indonesia and other countries, by NGOs, and by a lot of scientists who cite slash and burn agriculture as the ultimate cause of starting a lot of these fires. And we wanted to look at what are the more nuanced dimensions of this? Does slash and burn agriculture actually can we attribute most of the fires to that, right? And especially these subsurface peat fires. So in doing so, we ended up looking at the difference between fire ignitions, or the point when the fire actually starts, and the role of fire environments, or the sort of broader, biophysical dynamics through which the fire can burn, or the fire fuels that are on the surface and actually act as a conduit to the subsurface peat fire. Actually, I'm gonna go back for a second. So this is obviously very interdisciplinary work that we were attempting, and there's been a lot of calls in the literature for interdisciplinary approaches to looking at these systems, recognizing that most of these peatlands, especially the degraded ones, are inhabited and they have really complicated histories and many actors that have been involved in them, both local actors, but also the Indonesian government, other governments through their aid agencies and such. And doing this interdisciplinary work in practice is really quite challenging, which is why I think not too many people have attempted it. To push back against these simplistic explanations for human involvement in peat fire with an actual grounding in how the fire transitions into the subsurface requires both of the social scientists and the physical scientists, not only to work together logistically, which was quite difficult, but also, crossing some of these epistemological boundaries, right, over like what actually matters in the research, what questions do we ask, things like that. So this is sort of our best attempt. I'm quite proud of what we ended up doing, but there's certainly room, I think, to do more of this type of research in the future. So our field site was in the Mega Rice project, and I'm sure Laura will also be talking about this in Central Kalimantan. What you're seeing here is Block A, just a portion of the Mega Rice field site with the dip wells and the hydrology monitoring that the team has done for many years. My involvement in the project was really looking at data from 2014 to 2016. So 2014 being a kind of light fire year, 2015 obviously being severe fires, and I did a lot of these interviews that I'll talk about in 2016, so following up after the big fires. And you can see, as I'm sure somebody in the webinar has already mentioned, but you know, where the Mega Rice project was constructed in the late 90s was over one of the largest and deepest peat domes in Central Kalimantan. You can see on the right just how deep the peat is, and where the most extensive canals were built in Block A, just south of that peat dome, draining most of the water out of that peat dome, which has now had, as Pak Sigit really nicely described, you know, another example of severe peat subsidence and burning, of course, over the last couple of years. So there's some burn scar maps in our field site by Ibu Yeni. You can see the fires after the Mega Rice project in the late 90s were really severe in their extent. And then again in 2015 were also really severe. But you know, just looking at the extent of the fires doesn't tell us, you know, which of these fires actually transitioned into the peat soil itself, right? So that was part of trying to do this this research. So this project involved the bulk of it was really the team that Laura led in the field, the fire scene evaluation team, and I won't be talking too much about that. And that was the more quantitative side. So the fire scene evaluation team had a 69 question evaluation, and they were able to go out to active fires or recently burned fires in 2014 and 2015 and complete questions on the biophysical factors like the weather and the area burned and the fire fuel characteristics, the water table data, and all of that. And then what I did with my research assistant was come in 2016, and we did basically 3 different things. One is semi-structured interviews, which is a pretty typical qualitative data research method. So we interviewed a lot of people in the area in 5 different villages, district level and village level government officials, police and military officers, which are now heavily involved in fire prevention and fire response, a lot of local residents who do all sorts of activities and have different sort of stakes in fire use and land use in the area, and some oil palm company workers, which, you know, oil palm is a presence in the area, but this is not, you know, a landscape that's ultimately dominated by oil palm as some other degraded peatlands are. We also did this forensic fire scene investigation where we went with the fire scene evaluation team to sites that had burned in the previous 2 years. So these were not active fires, but by going with them to the site, they were able to sort of qualitatively describe to us the histories of those places as they knew them, because they were very familiar with the area, right? So they could tell us, well, you know, who was in the area at the time of the fire, you know, what activities had been going on previously. So this actually proved to be a really important source of data. Was sort of talking through the people that knew these sites most closely, right? Because they were there on the scene when these fires were burning. So we ended up added them to our interviews, our list of interviews as well. And then we did some active fire chasing, not too much when I was there. There were only 2 active fires that we were able to find. It was a pretty light fire year at the time. But seeing actually just these initial fire ignitions and where they were burning was really helpful in understanding, you know, why some people might have set fires, either intentionally or unintentionally. And I'll talk about that a bit later. So the bulk of our paper is really looking at, you know, the surface to peat fire transitions within a social biophysical landscape. And, you know, we started with some important observations when we were collecting the data. One, which is, you know, as I've mentioned, only some of these surface fires in peatlands, even though they appear to be quite large in extent, only some of those transition into the subsurface peat fire. So understanding what acts as the transition conduit is really important, and that's drawing on a lot of Mark's previous work. And then Laura had some great insights along the way, showing that the enabling conditions of this transition from surface to subsurface really relied on two things. And we initially thought it was the depth of the water table. That would be sort of intuitive, but we ultimately determined that it really came down to the availability of vegetation or the fire fuels and the composition of the fire fuels, the size of the fire fuels, whether they were fine fire fuels like grasses, something like logs in between, or smaller branches, right? And then ultimately the frequency and volume of precipitation in the area. So how wet or moist the fuels on the surface were really contributed to whether or not they acted as a conduit to the subsurface spread. And then another observation we made pretty early on was that the scale of the fires as they occurred in 2015, and I would say are probably likely to occur again, in coming years, especially in this site, can't be explained by human-led fire ignitions alone. And we observed this in part because the number of fire ignitions or hotspots that might have corresponded to fire ignitions didn't necessarily correspond to the severity of peat fires, right? Or the number of peat fires that actually occurred in a given year. So there's something more going on here than simply just, people setting fires. They spread across the landscape and into the peat surface. It's quite a lot more complicated than that on the kind of human or social political side. So in looking at, what were people doing on the landscape besides just say setting fires, right? If that was not the only reason why fires were spreading under some conditions and not under others. So one of our findings was that, fire use involves both fire ignitions, so, intentionally setting a fire using a match, but also this altering fire environments, right? So things that people are doing on the landscape to say move fire fuels around, like put logs in places where they might catch fire, altering the grasses, maybe they're chopping them down or burning them in certain areas. And also moving through the landscape, right? I think it's important to keep in mind that these are very inhabited places, right? They may not be densely inhabited, but there are people moving through them and across them in all seasons and for all sorts of different reasons. And, as they move through, whether they intend to or not, they often change the fire environment, right? In which a fire might come in months or even years later and be able to sort of, burn through that susceptible landscape as a result of sort of past activity. And in pointing this out, I really want to emphasize that we were really trying to pay attention to a lot of these dominant narratives, I think, that are quite present in Indonesia, but also in other countries of blaming, say, smallholders or village residents. While I think, yes, they do often set fires in this landscape, they're not, I don't believe, ultimately responsible for the scale that these fires have started to burn at, right? It's a bit of a mismatch. People have been living in these areas for, decades, if not hundreds of years, and doing all sorts of things that didn't previously result in these massive scale landscape fires that we're seeing now. And I'll, come back to that later. So a really significant piece of this research was premised by the particular history of landscape degradation in this site. I'm sure many of you are familiar with the Mega Rice project, but for those of you who aren't, the Mega Rice project was a Suharto era project in the late 90s to try to grow rice in this peatland using mostly Javanese style cultivation methods. They brought in excavators really quickly and dug these massive canals, much larger than you'd even see in what I've seen in most oil palm plantations recently. And of course, this resulted in severe drainage and rapid subsidence. It also happened to overlap with an El Nino year, so there was a drought at the end of this year, and a lot of this land caught on fire. As a lot of the transmigrants had already moved in, you can see these are rows of houses that were built really quickly on recently deforested peatland and near canals. And of course, the project at the time was sort of had a brief period of celebration, but was rapidly deemed to be a failure, especially once Suharto stepped down in April of 1998. But the repercussions of this project are still very much with us, right? Like this project fundamentally altered the landscape in a way that is proven to be quite irreversible. And has sort of underpinned a lot of the dynamics that are there now, both the biophysical dynamics, the scientific dynamics, but also the social and the political dynamics in the area. So a lot of the activities that we were interested in observing while we were there. We weren't able to observe them all in action, but we did interview a lot of people in the area that are involved in these things, or sort of told us about where people would do them typically, and in, with what frequency and what these things entailed. So, aside from, say, slash and burn agriculture, or burning through scrub brush to ahead of planting crops, rice, vegetables, things like that, there's many other sources of fire ignitions in this particular field site, and I would extrapolate to say these are activities that you would find in similar parts of Kalimantan as well. So some of those include deer hunting, selective logging, campfires that people set on the side of canals, salvage logging, and charcoal making. And just to really briefly describe why each of these uses fire, deer hunting, people will often set fire to grasses or sort of scrub brush, sedges or ferns just outside a forest to clear out and then encourage new grass growth, so the deer actually leave the forest to come eat the grass, and then they'll hunt them there. Selective logging is obviously illegal in this area, but practiced pretty extensively, especially in the last couple of years. And people will use the canals to access forest fragments, often clearing paths through ferns or sedges to get to the forest fragments, using fire to do that. And then also setting campfires, right, which is obviously an intentional fire ignition, but people, I think, don't necessarily intend for fires to spread beyond the campfires for cooking or something, but can definitely happen under the right physical conditions. Salvage logging was another activity we heard about, where people would go in and try to find large logs buried in the peat, underneath the peat, underneath the surface. And they would actually use fire to clear the area and then try to extract the log, and they would often cut it right on site and then take the wood planks to the local sawmill. So that would be another use of fire. And then finally, charcoal making, which is practiced pretty widely, but by some of the poorest area, village residents, often coming from quite far away. So actually having smoldering fires burning in wood to make charcoal that they bring and sell in the cities for very little money. So these activities all contribute to fire on the landscape, right? But again, there was, a bit of a mismatch between what we were hearing about, when people were doing these things and how often, and just the scale of the fires that were occurring. Some people emphasized that they would only do these things in the rainy season, or they would use controlled burns. I should also mention that the use of controlled burning for agriculture in this area is something that the Dayak indigenous communities have done for a very long time. But only in shallow peat, right? So areas where the peat depth is, 3 meters or less. And the fire in these areas really provides necessary soil fertility and nutrients to what's otherwise a very nutrient poor soil. It also is a way to clear out the really rapidly growing ferns and brush and grasses in the absence of having any sort of equipment to do that. So they've often needed fire, right, to grow things like rice that they sell at local markets, or to grow vegetables. Fire is now banned, and I'll talk about that at the end and what implications that has. But every Dayak farmer we talked to really emphasized that they were continuing to do the same things they've done for decades, right? Like make sure that they watch the weather. They would often sleep at their plot of land overnight to make sure that the fire didn't escape. So, and I think, there was a real, genuine surprise among a lot of people we talked to that, something they had done forever was suddenly both banned, but also no longer really sustainable, right? Like they also didn't understand why these fires were spreading, despite their best efforts to control them, right? So there's clearly something going on here besides just this intentional slash and burn agriculture, by sort of careless or reckless, farmers. So just to show you a couple of images. So this was photos from the fire scene evaluation team. I was not on this trip, but during the sort of height of the active burning season, you can just see the kind of, the scale of what a large fire fuel looks like on the surface, something that had burned and presumably had transitioned into a peat fire. That's what it looks like. I guess Mark can confirm that. The fire scene evaluation team measuring, the still smoldering soil. And then this was us returning to that same site a year later. And you can see just how quickly, first of all, this grass grows back after a fire. And initially how, by looking at this landscape, there was very little presence of people at this time, right? You can see in the sort of back corner, there's a slight pondok back there. But talking to the fire scene evaluation team, they would tell us so much, right? Like they knew, which members of the communities typically docked their boats nearby or set up pondoks in the area, or, when they might have been cooking or using campfires, things like that. So it was a really important source of information to try to determine like what sorts of activities were going on here, that might have actually altered the fire environment. So a couple of the things that, do alter these fire environments would be, so I didn't mention when I was talking about the Mega Rice project canal construction, but when the excavators came in and dredged up a lot of, soil and vegetation matter, buried vegetation from, to build the canals, they would actually leave the largest logs on the side so the excavators could move along a sort of canal, a logged pathway rather than, be stuck in the swamp. And those logs are now buried alongside of many of these canals, and the canals are used really extensively as transport, right? People access forest fragments, they go fishing, they use the canals to really just access the broader landscape. So they're quite active waterways at this point. And as I mentioned, people often set up pondoks and sleep and set up campfires. So one of the active fires we saw in 2016 was a recently extinguished, or it was actually still smoldering, but a firefighting team had just extinguished it and then told us that they had done so. So we were able to locate it. And we saw that the fire had clearly, originated with this campfire where people had been cooking. There was evidence of a pondok. It looked like they had been there just, the day or 2 days before. But it didn't look like it had accidentally actually spread from the campfire, but they had probably intentionally set a fire to the ferns that you can see and the grasses on the right side to clear a pathway to a forest fragment, likely to access, I would assume, logs, but there could be other non-timber forest products as well that they were looking for. So in cases where these sorts of campfires occur, right next to the canals that were built by the Mega Rice project, those fires that, might have initially started in grass or just meant to sort of clear out some grass to provide a pathway, can actually catch fire in these really large logs that are embedded on the sides of canals. And those large logs will act as the conduit to spread the fire into the peat soil. So this was sort of one of these examples of, unintentional fire spreading and acting, spreading through with this sort of altered fire environment in an unintentional way. We found that the soil was actually still warm when we got there and had, recently been sort of smoldering. The fire scene evaluation team estimated that, had the firefighters not arrived when they did, this likely would have transitioned into a peat fire. Although, that would be hard to prove, I guess, retrospectively. Of course, just more sort of, examples of people using these canals for logging. I want to talk about logging just for a minute. I think it's become one of these quite sort of vilified, criminalized activities. And, granted, there's very good reasons for that. It really severely degrades the ecosystem, even a small amount of logging in an already degraded ecosystem. But the selective logging in this area really picked up after the RED project occurred. So there was a series of RED or restoration projects that happened, as Pak Sigit mentioned and Graham mentioned, to try to do dam building or canal blocking in the Mega Rice site between, say, 2000 and 2014. And when these projects ended, a lot of the people that had been employed by these projects really had very few options, right? Their land is degraded, land that had once been accessible to them to, say, take out timber for their own building, was no longer available to do so legally. A lot of their farmland had been sort of overrun by fire. So many of them have turned to logging, right, in the area. And then people, of course, from outside of these villages, other parts of Kalimantan will also come. And this is part of the sort of whole local economic system, right, in which the sawmill operates and the police are involved in all of that. So it's really quite an insidious problem, right? Something like banning logging or calling it illegal doesn't necessarily disrupt these channels, especially when, a lot of these forest fragments are really quite accessible through the canals. And, as Graham had mentioned, they're one reason why a lot of the dams that were built early on to try to re-wet the peat fire were broken, because people could just easily break them, especially if they had been used to using these as active transport for, waterways. Okay, so here's just a brief mention of the fire ban. So when we were there in 2016, this fire ban had just gone into effect, after the 2015 fires. I believe it was initially a national scale fire ban, but then it was sort of, reaffirmed at the provincial level. And this was in one of the villages we were in, basically forbidding fire. Of course, it says don't smoke. I think there's a still pervasive assumption that cigarette butts, tossed cigarette butts will start a fire. We had never found any evidence of that, although maybe someone else here has since found evidence that a cigarette butt will start a surface fire that could lead to a peat fire. But we just, it was again a bit of a mismatch in scale, right? A tiny ignition point leading to these large landscape fires is not really the driver of the big fires, right? So, the fire ban was already having some pretty impactful, some pretty big impacts when we were there, and not in a positive way, right? There has been since some research that's come out showing that the fire ban has had basically zero impact on the number of fire hotspots in the past couple of years. But we were already hearing from village residents that, most of the responsible fire management that people had been practicing in the area for decades, was now criminalized, right? Like they were afraid of their village leaders or of the police that were tasked with going out to, basically try to fine or even arrest people that they caught setting fires. So, one of the other active fire that we observed was clearly set by someone who had, set a fire to very densely sort of growing vegetation on what looked like farmland, right? It was in shallow peat, and they had left, right? So they set the fire to the grass and they left, just hoping it would sort of burn and clear out the land and they could come back later. And, this practice of sort of, slash and burn and then run is, I think, become much more common. People were saying, either they're not burning at all and therefore can't use their farmland, which is actually driving them to find other livelihood, sources of livelihood activities, which drives them further into the landscape to do these other things that we talked about, including logging. Or they would just do exactly this, right? They would sort of burn and run and not manage the fire, not try to control it, right? So I haven't followed up on this, but I could assume that, the fire ban would continue to do this. I've found this as well in another part of central Kalimantan. So it's while it might be a logical sort of extension response, if you assume that, slash and burn agriculture is the cause of these fires, it actually doesn't necessarily, I think, have the intended effect, right? So another sort of conclusion, right, that I've mentioned a couple times is that, many of the activities done in this particular area that use fire have been done, for much longer than this landscape has been degraded, especially if we kind of look at the late 1990s as the real apex of sort of like landscape interventions that led to this long-term degradation that's proven to be quite difficult to manage or even to rehabilitate. And again, there's a complicated situation, I think, there where the people who are living there, right, they continue to both do what they've always done, but they're also increasingly constrained by the landscape degradation, right? So they're kind of forced into practices that increasingly lead them to either mismanage fire or to kind of penetrate parts of the landscape that they might have not needed to go to before, which spatially disperses a lot of the fire ignition points. So it's a kind of iterative process, right? A sort of feedback loop where the more degraded the landscape, potentially the more, spatially dispersed people are, the more landscape mismanagement, leading to possibly more fires ultimately. And then, yeah, as I sort of already talked about, the fire ban has really led to this poor fire management throughout the site. We didn't discuss this extensively in the paper, but I'm pretty confident that this is the case. And to sort of just highlight some of the limitations of the findings, right? So just keep in mind, I guess, that this is a really unique field site, right? Because of the Mega Rice project, it has this very particular history. And not only the canals that were built there in the 1990s were, some of the largest and most extensive, most dense across any peatlands in Indonesia. But since then, there have been so many other landscape interventions trying to rehabilitate or reverse some of this damage right? A lot of money and attention and scientific knowledge has gone into this place in ways that also really, I think, impact, impact our understanding of it, also impact the people who live there, and things that don't necessarily apply to a lot of other degraded peatlands in Indonesia, especially areas that have been, I guess mostly converted to oil palm plantations. There is some oil palm in this area. There might actually be more than now than since I was last there. But oil palm is not, the dominant land use in this area. In fact, there were a lot more people that we talked to that were trying to clear land with fire, to claim it, to sell to oil palm companies than oil palm companies actually interested in buying this land, right? Like there were the sort of rumors that oil palm companies might, come to the village and pay a pretty handsome sum for the land, was sort of driving people to speculate, right? To speculate on the land claims. And a lot of the oil palm, it just didn't really manifest because a lot of this land is not, it's either quite far from the rivers or the peat is too deep, or it would be very expensive to try to build the infrastructure there. So not as much of it has been converted to oil palm as certainly other parts of peatlands, especially the more shallow ones. But, we really think that the implications of this has a lot of, there are implications for other inhabited peatlands across Indonesia, right? Especially the need to look, I think, more particularly in a more nuanced way at the human activities underpinning some of this, right? This attention to fire environments, rather than just simply fire ignitions, I think was sort of an important intervention of this research. And to not simply say criminalize or criminalize local actors, especially while some of them might be setting fire, maliciously. A lot of them are clearly not malicious, right? They're severely constrained by the lack of livelihood options in this area, by the lack of state investment to reverse some of this degradation, and it's a really difficult situation for them, especially. And then I guess one thing I've thought, since we published the paper, is that with regards to the fire ban, something like a risk mitigation approach might be potentially more useful, right? So focusing on the activities that actually are most likely to lead to the subsurface peat fires, right? Assuming that surface peat fires will continue to happen, but if we're trying to prevent the subsurface peat fires and the sort of chain of events that leads to those, focusing on, land clearing for small scale agriculture in shallow peat is probably not the way to disrupt that chain of events, right? So enabling, say people to do supervised controlled burns in certain areas in shallow peat, I think could be permissible. Whereas, paying attention to the ways that people are inhabiting the rest of the landscape and trying to sort of prevent that, but also provide them with alternatives is really, really important. So I'll stop there. I'm happy to answer questions. And again, this was taken during the height of the 2015 fires. I think we're now used to seeing everyone wearing masks, but at the time, this was quite a dramatic photo of children wearing masks. So anyway, thanks again, Indra, and yeah, I'll stop there.
Okay, thank you so much, Bu Jenny. You're talking from the Mexico, but looks like you are here in Indonesia. Okay, it's always interesting to talk about the impacts of the human activities on the peatland fire. And also there's some interesting findings that Janice can grab from the fields. But still, hold on the questions. We will have Laura for another presentation. Laura.
All right. Thank you, Pat Indra. I will share my screen. Hopefully it'll come through. Just move this to the side, start a slideshow. Is that in slideshow mode?
Okay.
Okay, brilliant. Well, thank you to Pat Indra and to the IPB team for hosting the webinar and for being given this time to talk about some of our experience working with the NASA project. We are in phase 3 of the NASA project. We've been working with the University of Maryland, with Mark Cochran and with Pak Bambang and the IPB team since 2014. My organisation is the Borneo Orangutan Survival Foundation, and I think what I'd like to talk about today is there has been, as Mark mentioned, there has been a number of results and findings, and from the direct research that we've been doing that has had direct outcomes and use for us in the field, but also the other things that we have gained through capacity and knowledge exchange that has made us as a local Indonesian NGO better placed or with a greater experience to bring about successful restoration of tropical peatlands. So I would like to talk a bit about that today, about the applied use of the findings that have been coming out of the NASA project. So for those of you who don't know BOSS, as we are known, the Borneo Orangutan Survival Foundation was established almost 30 years ago. And whilst we do, of course, prioritise the protection and conservation of wild orangutans, we are well aware that we can't do that without protecting their habitat, without engaging and empowering the local communities who live in and around that habitat, that we need to have research and education activities appropriate to protecting that habitat, and that within that we need to work with a wide range of different partners and stakeholders, and that we also prioritise on working together with our institutional partners and strengthening capacity. So BOSS has 4 programs across Kalimantan. The one that I work with is BOSS Mawas, which was established almost 2 decades ago. It focuses on a single tropical peat dome or a single hydrological unit that's located in central Kalimantan between 2 big rivers, the Kapuas and the Barito rivers. We're really appreciative to our government partners. The area is protected forest under the Ministry of Environment and Forestry, and we work closely with the forest management units in Kapuas and the Conservation Agency to help them achieve their visions and mission of protecting this forest. It's 309,000 hectares, and in its natural state, it would be tropical peat swamp forest. And up in the north, where more of the forest is still in an intact state, it hosts one of the largest remaining orangutan populations at over 2,500 individuals. And all along those rivers, there are 59 villages, so you can see why it's so key that we also focus on community engagement and empowerment. Just a little bit on the ecology, which of course Keith earlier also presented on. So tropical peatlands are normally found between 2 rivers. The distance between the rivers can be tens of kilometres, and the depth of the peat can be up to 10 metres of organic matter. In their natural state, they should have this peat swamp forest covering their surface. And this relationship between the peat and the forest is really key. Of course, it is the forest that creates the peat. It's the leaves and the branches and the roots in the anaerobic conditions that create the peat. The canopy of the forest also create this humid and cool microclimate that keeps the peat moist and in its comfortable state, natural state, and the tree roots are holding the peat in place and also keeping it aerated. So what that means, if you're trying to protect the biodiversity, if you're trying to protect the forest, if you're trying to protect the carbon in the peat, you have to focus on that whole ecosystem, just not one aspect. And equally, when you lose the forest from the surface, you very quickly lose a lot of the important characteristics that define the peat structure as well. And as we heard a bit about from Jenny, unfortunately, this area where we work has had some serious degradation and forest loss in the last couple of decades. So the Mega Rice project was established by the then Indonesian government in the 1990s with an aim to facilitate Indonesia to become self-sufficient in terms of its rice production. And to do that, it established over 4,600 kilometers of canals. Equally, local community members will hand dig small canals through the forest in order to enhance access to extract forest produce. And so, of course, once you do have canals, it increases human access, and selective illegal logging also often follows close behind. And so what that means, that kind of combination of all of those factors, means that you have a lowered water table from the canals, you have increased disturbance and fuel load on the surface from the logging, and with regular human presence, as Jenny described, then you also have this almost annual occurrence of fires. And that map image there with all of the red dots over it, they indicate the hotspots that were detected across the southern half of the Mawas area in 2015. And to put it into perspective, the photos alongside the map, the one at the bottom is what the big roundabout in the center of town in Palangkaraya, where I live, what it usually looks like. And then up above it is what it looked a month earlier before the rains had come in October 2015. And honestly, it was terrifying to live through. So what that means with the logging and the fires is that 309,000 hectares of protected forest where Mawas works, we've now lost about half of that forest cover. And despite best efforts, we are still losing more forest, and that's impacting on orangutan population too. So as a conservation NGO, as I said, we're prioritising the conservation and the restoration of the peat and the forest for the biodiversity, which equally means that we need to gain knowledge and experience to manage these fires that are devastating the area. But we are well aware that this is going to be a long-term solution, that we can't solve this problem easily overnight, that it needs a wide range of different disciplines, approaches and activities on the ground, and that one of these is going to be environmental monitoring and increasing our knowledge through research. Which is why, as I said, we've been really glad that we've been partnering with NASA since 2014. And what I'd like to do now is walk you through some of the lessons learned or the findings that have really enhanced our efforts on the ground within BOSS. So the first thing to understand about what we're doing, and a little bit of history, in 2009, the Kalimantan Forest and Climate Partnership, which was a RED demonstration project funded by the Australian government, was established. And it was enabled us to set up this really unprecedented scale of landscape monitoring across an area of about 120,000 hectares. So it was really exciting to be able to look across all different kinds of the peat gradients and hydrology gradients. And so what that means is we were able to set up hydrology and peat monitoring, vegetation, fire and fuel. And then when the KFCP project ended in 2013, Professor Mark Cochrane had already been affiliated with that as a research specialist. And so he was able to attain funding from NASA to keep this really special landscape scale environmental monitoring going, keeping it going. And so what we now have is 300 dip wells, 33 staff gauges and 62 subsidence poles that cover 60 kilometres of transect, recording the hydrology and peat. We have 96 permanent monitoring plots that are spread across a range of natural and degradation histories across the area, representing different forest types and degradation types. And then we have, which was the main focus of the NASA project, this large number of fire scene evaluations and fuel load data collections, which I'll come back to in a second. And all of that data is managed by BOSS, and then of course we share that with IPB and the University of Maryland to use that in all the different models and analysis that they're doing. So when we started this with the NASA project, and we wanted to enhance the fire monitoring that we were doing on the ground to better understand why the fires were starting, what the fire behavior was, why they were transitioning into the peat. We quickly realized that there wasn't well established or standardized tropical peatland methodology. So the very first thing to do was to establish how we were going to do this, and to do it in a way that could be consistent and rigorous and replicated across multiple areas with people who perhaps don't have a lot of fire ecology background. So as Jenny mentioned, we developed this fire scene evaluation that's split into two parts. The first part really focuses much more on the location of the fire, the environment, the climate, the weather conditions at the time, access routes, ownership of the land. And then the second part is, if the fire is not just a surface fire, but it has transitioned into the peat, then we start looking at the different peat fire behavior that is happening. And you can see on the left-hand side, the photos and the diagrams are the ways in which we look at the rate of peat fire spread, the moisture content in the peat, and the volume loss, which I'll come back to. So returning to the main objectives of NASA, which was one of the objectives was to improve Indonesia's ability to calculate carbon emissions from peat fires. Well, if you start at the formula, which in itself is not overly complicated, and Mark Cochran also talked about this a bit in his presentation in the last webinar, is that in order to know the total emissions from a peat fire, you need to know the area that's burned in hectares, the depth of the peat burn in centimeters, the amount or the percentage of fuel that was consumed, and your fuel is the peat or the peat and the logs below ground, the bulk density of the peat, and then the emission factors, which is what different gases are coming out of the peat. And so as IPCC describes, there are two approaches that you can use for doing this. Either you use top-down techniques, which is using remote sensing data and using models, which provides you with really important landscape and even national level data to really predict over a wide area. And so that's a tier 1 or down to tier 2 approach. But then these models and remote sensing techniques, of course, need to be verified and calibrated by actual data collected on the ground. And that's this bottom-up tier 3 approach. And unfortunately, to date, there's still very few studies that are actually doing that tier 3 focus. So it's difficult to verify the validity of some of the models. So what we wanted to do was focus on our peat dome. It's only a single peat dome. It's not a national level analysis, but it's going to be a micro scale study that really gives bottom-up ground data. So also in the first webinar, if you were able to join, you would have heard Jenny Vetrita presenting on her research, which has focused on the Mawas area and created very detailed burn area maps to show how much of the area has burned year on year and how frequently it's burned. So that's giving you area on a landscape scale. But then where we come in is we then go and we develop this methodology that allows a very detailed measurement of the peat volume loss. So if a fire is reported and we go out and we're ready to conduct a fire scene evaluation, if the peat is burning, so it's not just a surface fire, we'll set up this grid that's made of plastic poles and netting. And we use that to become a X, Y, Z coordinate system that allows us to create a very detailed micro topography of the peat surface. And we'll set that up just ahead of where the peat is burning and looking at the direction in which it's moving in. We measure the surface of the peat and then we put in iron rods so that we know where the legs of the plastic grid was, remove the plastic grid, which will obviously burn, come back a couple of days later, and usually by then the area has burnt through, the peat has burnt through, and we reset up that grid using the metal poles to know exactly where we set up the grid and at what height, and we re-measure that topography of the surface, and that then gives us a very detailed volume loss in terms of the area on a micro scale, the depth, and also the percentage of fuel consumed. And the early analysis that's coming out from this is, of course, as you would expect, location is really influential. Your distance from the canal, the vegetation cover, how many times the area has burned previously, but also how far you are into the dry season, which links, of course, to the water table depth, also has a really big impact on the kind of volume loss of peat that occurs when a peat fire goes through it. And so that's some aspects that could be incorporated into the models that would provide a higher degree of accuracy. And then going back through the formula, so we've got the area, we've got the depth of burn and the percentage of consumption. We also need to know something about the density of the peat. And so through this environmental monitoring campaign, large pits were also dug into the peat, 2.5 meters in depth. And every 10 or 20 centimeters, peat samples were collected and measured for bulk density. And so that data showed us the way in which bulk density alters, yes, down the peat profile, but also in relation to how far you are from the canal, again, the fire history and the vegetation cover. So again, that's a degree of detail that can be added into those models. And then finally, and as I think we'll hear more about from Pat Bambang and also Bob Jorgelsen in the third webinar, we also had some very sophisticated technology come all the way from America out to the peatlands, and was able to measure what physically was coming out of the peat when it was burning, what was in the smoke and the particulates, and we were able to get really detailed emission factors specifically for this peatland area. So what that means then now in terms of total emissions of peat fires is now for a single peat dome, we have all aspects of that formula done at a tier 3 level, which provides a degree of accuracy, which can then help verify and calibrate the other models and remote sensing techniques. So that's been a really important product for the NASA project, but also for us engaging with government and helping the government to quantify and talk meaningfully in these carbon markets that are developing or influences to the carbon emission calculations. But then aside from just collecting data with a direct research output, I'd also like to just very quickly go through a few of the things that Boss Mawas does on the ground that has also really been helped by the knowledge and research outputs of the NASA project. So one of the things we prioritize is village-led fire management. We've worked with a number of villages in the area for over a decade to help them to develop their own fire management strategy so they can go out and control and manage that system themselves. We also ourselves conduct several monthly patrols to look out for illegal logging and fire activities. And then we have a rapid response team that goes and puts out fires as well if we encounter them. So as we heard about from Keith earlier and also from Jenny, with this enhanced data that we're collecting with the fuel loads, with the fire and peat fire behavior data, with the hydrology and moisture data, and the fire associated human behaviors, now that we're starting to understand those, it gives us a better means to predict or understand the high risk areas, the high risk seasons that are going to potentially have fire ignitions, high rate of fire spread, and transitions down into peat fires. Equally, as we talked about, there's been a lot of effort to block these small canals that are across our area, and as Pat Seagate was talking about as well. And we work with local community members where we all offer alternative livelihood compensation packages in return for gaining ownership of their canals. And through this program, programme, we've gone in and blocked approaching 200 small canals across the area. The hydrology monitoring and models that Keith is talking about, of course, are a direct research output. But what we also have been doing is really looking at the methodology that we're using for hydrological modelling and trying to make improvements in those systems, and also all across the BOSS team, not just the research team that works with the NASA project, but with the reforestation, the canal blocking teams. They've also gained capacity and knowledge in the best way to accurately monitor and record the impacts of these canal blocking interventions. So it's providing us with the means to report back to donors and village government and village communities to say this is the impacts of blocking the canals. As I mentioned, we now have this series of almost 100 permanent vegetation monitoring plots across the area, and they cover a range of forest types and degradation histories. And so what that data has been used for internally by BOSS is to focus on the forest fragments that are remaining where we have plots, to really better understand the role and the impact that those fragments still have and really need to be prioritised for conservation. We also then look at which areas are actually managing to successfully regenerate, which areas are struggling that maybe have some regeneration happening, but it's not quite getting there, and so they need some assisted natural regeneration techniques such as the weeding or the fire management. And then it allows us to prioritize the areas that really are not getting anywhere in terms of forest recovery, and those can be the targeted areas that we prioritize for the expensive reforestation efforts. Also, just to talk a bit more about what Jenny mentioned throughout her talk, was this close relationship and this open relationship that has been developing as a result of the project in terms of improving knowledge exchange and understanding with the local community members about issues over fire. We're fortunate that because a lot of the villages where we are largely Dayak communities, culturally they already have a very close relationship with the forest. They appreciate the environmental services that the forest provides them with, and they want to see it there for future generations. So their approach towards restoration is usually supportive and encouraging. But equally, it is a very remote area. Health, education and livelihood options are really limited. There's issues over land ownership. And as Jenny mentioned, fire has been used as a tool across this area for centuries. So through going in with the communities, having these detailed discussions that haven't focused on prosecution or accusation, but have focused on understanding and knowledge exchange, have really helped us better understand the issues facing them over land management, fire use, and so on. We also prioritise making sure that we socialise all of our activities with the local community members, and that we recruit staff locally, both for daily staff and our permanent staff. And then finally, of course, we are really dependent on the communities. They're the ones who report the fires to us a lot of the time, and they're the ones who help us collect the data about the causes and the motivations. So it's really improved this relationship of open knowledge exchange. Finally, I would also like to mention our government partners, the provincial government of Central Kalimantan and the district governments of Kuala Kapuas and South Barito. For all of the projects that BOSS runs, we provide monthly reports, participate in working groups and meetings and so on about all of the different activities. And so what that means is when the NASA project has had workshops and training events locally, we've made sure that we've invited our government partners, and again it's led to a really enhanced knowledge exchange. The data that's coming out of the NASA project is being directly conveyed and applied by local government members as well. And so as I said, BOSS as an organisation, yes, we are prioritising the long-term sustainable protection of wild orangutans, but we can't do that without addressing the fires. And we can't do that without being holistic and integrative in our research and restoration efforts. And so I hope that this presentation has shown some of the direct, really valuable outputs of the NASA project, but also the way that through partnership with academic institutes and NGOs and our government partners, it's a really positive way to facilitate knowledge exchange and experience and understanding that are going to be key in stopping the fires and haze in central Kalimantan and across Indonesia. Thanks very much.
Okay, thank you, Laura, for your brief talk on the role of the project to prevent the pit fires there. Okay, and now we are moving to the final talk of today. Asmadi, okay, time is yours, Pak Asmadi.
Yeah, thank you, Pak Indra, and all the people here. Can I share the screen?
Yep, surely, please, Pak.
Okay. I have to change it. It's the PDF. Stop. Halo, Pak Indra? Oke,
Ya,
Oke,
Oke,
oke, Pak.
sudah ready.
Oke, terima kasih. Baiklah, I would like to present the lesson learned from the hydrology monitoring in Jambi. Jambi, we have started monitoring the water level 2011 with the semi-zoo operations. Last times we do in the peatlands and the coastal Jambi. It's very important if you would like to monitor the water level. This time that we have to know the characteristics of peat. It's important based on our experience. It's the tropical peat. They made from woods, log, and insides. But in the peats for the boreal peats, I mean in the Finlandia, made from the sphagnum, it's very different. It is soft and very homogeneous, is heterogeneous, one side to the other side. We see in Jambi until 750 centimeters, it still keep fit, and we still find the log inside and the coarse material. It's the very dangerous 2015 very hard fire happened in Jambi, in Indonesia too, Sumatra and Kalimantan. It's the very dangerous. After 10 days, fire still happened there. So it's not just surface fire, but inside, underneath the peat. The impacts we see 2015, the water about the location is very, very low. No water come out from the peats because no water available for the peat. We see it's 2013, 2014, 2015, January, it's July. It's very important, we have to know that. We have to be sure about that the water water table, groundwater table. In the example, fire 2015 burns a lot of the area in Jambi. But 2018, we have repatriation or restoration there. We have the blocking canal, repatriate, but 2019, it's fire day. Why? Fire not just surface fire, but go inside. It's very different. If we see what is satellite image, we see start burning Augustus Z1 2019 is fire condition. 9 Augustus 8 September, yeah? 8 September 2019, we see 18 September all months. But that time fire not go inside slot. It just surface because the many blocking canal has met that time. But the other sides, there are a lot of the fire spot. I think it's burned by people. So for Jambi, we have recalculated the area of the forest fire. 2015, 115,000 hectare. 2016 go down, but 2018 1,000, but 2019 it's dry, enough dry last year. We see that place, it's the pit depth. But always fire happened in Jambi, here, the long run, and here. Why? Many factors, just not water level. But the people too, like Jenny and Laura mentioned about it. We see our experience start 2015. It the pit depth water table in the dry season, water table in rainy season. It's the October, November 2015, but it March 2016. We see the water level is still that. Burning, 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 2015. Is the water table in the canal is still low too, but not enough water to fill out because too much water come out from the pit. So some company must to do by the pumping water to revetting to distribute the fire. If not that, fire keep continue. 2011, we start to measure the coastal from the coastal and the river come into the primary canal, secondary canal. We see the how to do that. We make the conclude that the water or in the fields always impacted by the tide if they closely to the sea or the coastal. If not impact, just the water from the river and from the rain. And 2013, we start with sesame. We do it, we put support as the rain winning system to know the water level to protect the food fire. We have to measure the manual and we put it the forest, oil farms, and the acacia plantation. It's very different. If we see it, groundwater table manual measuring, the conservation area is not but higher than the sesame we install on the local oil palm plantation. See, the water table higher. But close the system, we install the deep well monitoring. We see the water lower, but not too much. But in the acacia, you see it until 120 centimeter underground. You see it, condition, it's the canal. It's doing by Sirio, my student, yeah, in the Jambi University. 2018, 2019, we see it. It's the rainfall, and below is the water table. When the rainfall hikes, groundwater tables higher. But 2019 start June, July, August to September, no rain is the problem that time. It's so as we have to keep the water as much as in the rainy season to keep in the pit as the preparation for the next rainy season, the next dry season. If not enough, we keep the water, no rain, water table go down. It's the problem. We have to do it and keep it. Sometimes the company and the other corporation forgot it. They just to keep the water, but not to prepare water for the dry season. It's very important. It's our experience. Yeah, we measure that. It's the farmer in Tangkit. Yeah, Tangkit is one area, one spillet in Jambi. The farmer grow the pineapple since 1960. Until now, it's keep okay. Good productivity, no fire. We see it. We measure, we install 10 water monitoring and 10 subsidence pool here. We install. We see the water condition. Just one full, one side until 110 centimeter under. It just happens on the October. But the others, it still keeps 60 maximized and 40. But the water, that positions still keeps the moisture, hides moisture at the surface of it. It cannot be burned. We need a lot of energy and hot can be make fire. If not happen fire. It may be just only for the surface, but pineapple contain a lot of the water plant, also cannot fire. It's water table on pineapple plantation Tangkit. You see it? Groundwater table. November 2018, you see, not to that. But in canal too, we measure water table at canal, but the pit, white canal and depth of pit, depth of the canal, we see the water here. It's okay until now, no fire. We see in the Hollandia, we see it like this. They don't make the large canal and deep canal. And they didn't make the too big, too large of the blocking canal. It's just a pretty simple, I think. Depth here about the pitch or the 4 meter, it's okay. Experience is Jambi. When the farmer keeps the water level is high, like this Sinarwajok village, we see is the blocking canal, no fire here. But the inside, when the farmer for the oil farm plantation, they grow oil farm and makes a lot of canal and deep, makes fire. close to the Sungai Buloh conservation area. Experience 2015, we see it. It's no blocking canal here. The fire in the Tahura. Tahura, it means the peatland conservation, Orang Kayu Hitam. All burns 2015. And then start 2016-17, many NGO and governments makes the blocking canal inside. Here, we see now it's the blocking canal, and here we see the impact inside. The water's height, no fire, but on 2019, fire still happens, but just slightly, just only the surface, not inside. We see it. But the oil palm plantation, they do measure the water, groundwater table too, but they control pretty strictly the water level. You see here, it's one company in Jambi. They control it. It's good. No fire, good productivity. In 2020, I come to see again in the Tahura. We see here about 100 meters from the blocking canal, the water still 23 centimeters from the surface. It's good. It's cannot very wet. Yeah? It's very wet. Cannot fire. But now, government of Indonesia by the BRG install a lot of the Sifalaga. Until now, about 154 Sifalaga have been installed in Indonesia. Jambi, Kalimantan, two, West, South, and Middle Kalimantan, Central Kalimantan. For Jambi, we see the rainfall, groundwater table grabbed. You see that? But the important is we don't know how large the area can be sown by the one Sifalaga installed. So we see here, now we are doing research with the BRG. We have to collect the groundwater table from field monitoring, topography, rainfall from the environmental, and peat characteristics. Is the importance. If we don't know the peatland characteristics, maybe degree of the composition and peat depth and characteristic the other side. It's important to know how the water can go, permeability of the water of peat for the water inside, or infiltration. It's important. And how large the area can be sown by the one of the Sifalaga. Now we have installed 25 unit 5 monitoring and 1 ombrometer for 5 sites. Yeah, we have installed 5 sites. So Jambi now have 5 sites and 2 sites again before we have installed. So we have 7 location field sites for the study of peatland and monitoring of the water level. It's important for future. We hope our university will support us to do that. And we would like to know how many meters from that Sifalaga can support data for the water level. It's very important. Until now, we don't know that. So we will measure groundwater level every day during 2 months. Money just for 2 months. For the next, we have to find the other money, the funding to do that. We have to install. Based on that condition, my friend Dr. Zuhdi calculates. It's the very, very little data, just for 1 week. It's the very, very that sound that Sipalga can sell about the 3,276 meter from the installation can be sure the water level. But I'm not sure and not believe that. We have, after 2 months, we have to collect a lot of data. I think can make me sure. But now, no. It's very important because there are many things we have to measure in the field: soil characteristics and canal tube, and directs of the water go. It's important to measure in the field, not just the height of the water, but the water going on. It's important. So the system canal in the field, it's important for us to know the real how the water we measure it's accurate. If not, just we got data, but not meaningful for that. Yeah, I hope for the future, by the 7th station in Jambi, we can produce the good data for the future. So, can give good lesson learned, water level monitoring for the hydrology, at least in Jambi. I think, thank you. For the conclusion, we can conclude by ourselves. Yeah. But the end, I want to say to the young kids, people in the field, tolong kamu jaga gambut desa muna. It's been have to keep the peatland in your village. It start from village, not start from the Jakarta, not start from the sector, not start from the other institution, but start from the village. Yeah, I think, thank you very much. I think we can go the discussion. Thank you. Terima kasih, Pak.
Okay, thank you, Pak Asmadi. I love your last statement. Yeah, I love your last statement that we have to start prevent the peatland from the village, yeah, Pak, not from Jakarta. Okay, I like it. Yeah. Okay, ladies and gentlemen, so we still have around 30 minutes for discussions. So we have a lot of lesson learned from the link of human activities to the peat fire, and also we have the lesson learned from Kalimantan and Sumatra for this hydrological and also vegetation analysis. So there are already 3 questions for Bu Jenny. Sorry.
Do you want me to take them all together, Pragendra?
Yep. The first one is from Professor Imas. Based on your qualitative research, do you find the relation between education level of community to the fire occurrence? What is your recommendation to increase the community awareness on the peatland fires?
Yeah, that's a good question. I mean, I think that question could actually be read in 2 ways, right? The first part, I don't know if you intended to ask this, but I read it as asking about, if people are more educated there in general, say achieve higher levels of schooling, are they less likely to contribute to the fires, right? The second question is actually asking, should we educate the communities about the fires, right? Implying, should we educate them to stop setting fires? So I can answer both. The first part, I don't have much research on that myself, but yeah, I mean, the more schooling I think people achieve finishing high school, even if they were to go on to higher education, that really changes people's, you know, livelihood, professional opportunities. So I think that overall could have a really big impact. But, you know, specifically in this field site, I'm a little hesitant to sort of use the phrase education, because I think to me that sort of implies that people there are ignorant, right? And they need to be taught better so they learn, and then they won't be ignorant anymore. And I think Laura actually did a really great job of highlighting, you know, the work that Boss and other partners are already doing. That's not really focused on education, but it's focused on engagement, right? Because in my, you know, I've worked in this area for about eight years now and done, you know, dozens of interviews beyond just this project. And I've never really encountered people to be ignorant of their local environment, right? I think they very well understand the detrimental impact of the fires. People there certainly don't like to live through these severe fire episodes. They understand the environments very well. You know, and I think in a lot of cases, they just feel like things are out of their control, right? So, you know, could there be a way to have engagement to sort of, as Laura say, like redirect or say prioritize certain areas, right? And work with the communities to prioritize certain areas to protect at certain times of the year if they're at higher risk of peat fires. I think absolutely, right? But a sort of blanket statement on education, I would shy away from, because I think people there are definitely not ignorant, right? And I've heard many different ways that they very well understand even how remote sensing satellites work, right? And how they could possibly evade hotspot detection and set fires, say, during the night when they wouldn't be caught, things like that. So, you know, there's all sorts of ways that people who, you know, are have the will, right, to try to either, you know, make money or feed their family, right? They will do what they can to do that. So, I don't know if that answers your question, but those are my thoughts. I guess I'm not totally clear on what the second question is asking, whether we saw any specific evidence of the cause of a specific fire. Do you want to clarify that, Acep?
Acep, okay, this for the second question. Pak Acep, Jenny, Pak Acep, can you clarify what is your question? I think the question from Pak Acep is related to the evidence. If you are going to the field and you see that there's a fire in the field, so how you can say that this is the evidence of the fires based on the signs or mark that you can see in the field?
Yeah, I mean, as I mentioned, you know, when I was there, we only witnessed 2 active fires, right? 2016 was not a heavy fire season. And I think in some ways this is an analogy to what Laura was describing of moving between tier 1 at the sort of national scale of analysis to the micro scale at tier 3. And I think, you know, the work we've done with this project is somewhere in between tier 1 and tier 3, right? We were trying to move from a sort of blanket understanding of fire across all peatlands in Indonesia to understand the more micro dynamics. But at the same time, I mean, if you want, you know, really concrete evidence of fire causality, you have to actually witness the active fires, and even better, you'd have to witness, you know, when the fires were actually set and how they spread, and do that sort of observation, which for obvious reasons is very difficult to do. So, you know, I mean, the 2 examples I can draw on, you know, that we saw in the fields, one of which was the campfire example I showed you, where, you know, we were there with the fire scene evaluation team, and they pointed out that it looked like the fire had been deliberately set to the ferns and the grasses nearby to try to clear a path, right? And we saw the path that had been cleared so they could probably access the forest fragment, and that went all the way back there. You know, do we have definitive evidence of that? Not really, right? But that was sort of our best inference. And the other fire we saw was, you know, had just been set within the last couple of hours probably, and it hadn't really burned that much yet, but there were like 4 or 5 ignition points in a sort of dense grass area on farmland in the shallow peat at sort of regular intervals. So it looked like somebody had deliberately set you know, this fire to try to spread it through the grass, and it would merge and then clear out the area. And they had, you know, clearly left the area to let it do that during the day. So again, like, do we know the motive of why somebody do that, or whether it was actually their land or maybe it was a neighbor's land? Like, of course, we don't know, right? We didn't meet the person, but that was our observation. But I'd also just like to say, I think finding the specific cause or intention of a specific fire was also not really the objective of the research, right? It was to try to understand how human activities in general create these fire environments that are enabling these landscape scale and very severe peat fires, right? So it's much more complicated than just being able to identify a specific cause, because, you know, in some ways the causes are endless, right? People use fire, they will always use fire, right? So just because we could, you know, even if we could observe a couple of fires in the field, you know, I don't know that that would necessarily give us the information we were looking for, which is a much more holistic picture of how, you know, the politics and the economics in that area contribute to the use of the landscape. So yeah, there's just one question. I don't want to talk for too long. Yeah, I think I maybe just answered that question. Forgot to mention they cleared the fields and leave. Yeah, I mean, we observed that in the field, right? And we also heard that from several people we interviewed, that they were practicing that, or their neighbors were practicing that, because they were afraid of being caught, right? They very well knew the police were out looking for people setting fires, or their neighbors would report them to the village, you know, the Kapala Bati, Kapala Desa, sorry, and they're very scared of that, right? And people are starting to, you know, I think turn on their neighbors in some cases, right? It's not as cooperative as it used to be in some cases, especially in really degraded areas. Of course, Laura's, I think, evidence shows there's also great cooperation and community engagement. So yeah, anyway, I'll stop there.
Okay, thank you, Jenny. It's quite interesting to talk about the cause of the fires, but I think this one is related to the fire skin evaluation. Have you any comment on this, Laura? I think you want to make any other comment on this question?
Well, I suppose, and I mean, I think most people on the NASA project, we're also working with PAACHEP in a partner project in the ACR project, and PAACHEP has also, it's been one of the nice things with the NASA methodology that it's now not only being used by our partners in Riau and Jambi, but also it's been adopted by this Australian funded ACR project and being used in Pulang Pisau and South Sumatra as well, which means that we now have 5 studies and 5 sites across Indonesia that are all trying to collect data in this consistent manner. And I think Graham Applegate will talk in the next webinar about, you know, the development and the applied use of this fire scene evaluation. So ACHEP has been one of the team that's been learning to use this methodology. And I think the only thing I would add that's more a comment than answering his question, but perhaps goes more towards less the research findings and more about this development of methodology and capacity building across our either academic or government partners across Indonesia to collect this data. When the NASA project started, and we were very fortunate to have Mark Cochrane and also at that time Kevin Ryan, who have been fire ecologists for several decades and very skillful at collecting fire data, but also reading. And I think that was the thing that we realized. It's a skill that's developed over years to interpret a fire and what's happened, why it's happened, you know, to read the vegetation and the soil and the human part and the access and the land ownership. And Kevin and Mark were very kind of fluent and fluid at just creating these really clear fire narratives, we were calling them, at how you describe a fire event. But unless you've been learning this skill for years and years, it's actually very hard to replicate that. And so that's what we were trying to do with this fire scene evaluation and the 69 questions, to facilitate people like me and my team who are not fire ecologists to go into the field and collect data consistently and that would be quantifiable would kind of, so we took Mark and Kevin's fire narratives and broke them down into 69 questions, and that with the hope that at the end of this 69 questions you can build it back up into a fire narrative. And so I think, as Jenny said, and also as perhaps Pat Achep is trying to find, sometimes one question is very tricky, or sometimes, you know, one aspect is, it's not always, it's very hard to record fire data in the field. But I think it's, as Jenny said, it's not just about one question, it's about this fire narrative that comes out of the end once you've collected all the data, and then you collate all the different fire scenes, and you start to begin to see the trends and the patterns and the behavior. That is, you know, why we're very glad that we have people like Mark and Bam Bang on our team guiding us, because it is definitely a skill that takes a long time to learn. And I think that's why we hope that this fire scene evaluation methodology can become useful for multiple institutes, because it takes away that years of skill and hopefully makes it replicable for people who are competent in the field, but not perhaps fire ecologists.
Okay, thank you, Laura. And thank you, Prof. Jenny, for the brief answer for the questions. There is another questions. This one is for Pak Asmadi. Pak Asmadi, how you decide to build position to establish the canal block? This one is from Pak Mulyadi from Yayasan Gambut. If we don't have a map of microtopography on Peat, and how do you think there is a compaction on the Peat? Because recently the plantation did the compaction on the Peat before they did a before they started planting. But do you think that this compaction, this action to compact the Peat is really prohibited by the regulation? So what is your idea, Pak Asmadi?
Yeah, thank you, Pak Indra. Yeah. How to decide to build the position of the stabilize of the canal blocks? It's important. So many questions. It's mentioned by the many people to me, by the other discussions. Based on the theory and the concept, you have to protect the water level. How high? If you would like to make it the 40 centimeter, so it at the side 20, at the side there 20. So we keep, when the water different 20 centimeter, we have to build the canal blocking. It's the theory, but in the field it's very different, because the many factor will influence that. The most important for me, based on our experience in the field, we see we have to make it after 40 centimeter different. We have to make the canal blocking, and relationships we have to make the compaction Peat and compacted Peat regulation is prohibited, because the compacted will reduce the functions of the Peat to store the water, but the compacted Peat can make the Peat go down about the 20 until 40 centimeter. I see in the field by one company to do that. I think it's not good, yeah, for the Peat concept. And microtopography, Peat, you see, all people didn't have the map of the microtopography of Peat. Who have it? No. I think the topography on the Peat, once mapped, or once the Indian one Kahage peatlands unit, hydrological peatland unit, is the different. Sometimes the one dome, two domes, it wants the hydrological unit, yeah. And for Pak Bambang, can I directly answer?
Okay. Okay,
Indra?
please. Okay, please.
Yeah. Do you have suggestion? Apakah you have suggestion for peat fry 2019 increase very significant than 2018? And using if it's because not being blocked the canal? Yeah. Can I show the screen one again? Or for the 2018 and 2019, 2018 the water still hikes and rainfall enough. But start June 2019, the rainfall is very low. But the water available on the peat not enough. Evapotranspiration hikes, temperature hikes, so evapotranspiration hikes, and no rain. It's not the same cases which the peatland, the coast are closely to the coast. Impact of tides is different. It's happened far away from the coastal, not impacted of the influence of the tides. So in 2019, many of the blocking canal not enough, doesn't work well to keep the water in the rainy seasons for the dry season. It's important. We keep the water not just to maintain the water on the 40 centimeter, but we keep the water for the next season. During the raining, we keep the water a lot of, but in the dry, the water come out slowly, very low, and evapotranspiration hikes, but we have still enough water in the peat. I see many places blocking canal doesn't work very well. Like the Tahura, I showed you before in my screen. 2020, the water is very high because the blocking canal works better, but it's not enough. When the dry season, the hair still keeps a lot of water. And one hydrological unit, there are many people there, institutions there, many system hydrology, farmers, yeah, and the corporation, they have to now collect it together, not just keep themselves, but together. It's important. I think it's from Bambang. Thank you.
Okay.
Makasih Pak Indra.
Yep.
Yeah.
Thank you, Pak Asmadi. Thank you for your answer. And there is another question from Pak Adam. I think Pak Adam want to ask directly to Bu Jenny. Please, Pak Adam. Pak Adam, your voice is not.
Can you hear me okay? Is it working now?
Okay. Okay. So
okay, good. Sorry, I didn't think I had time to write the question, but so I'll say it instead. Firstly, I wanted to thank all the presenters today. I've found this session very useful and very interesting. Thank you for everybody. In particular, I want to address two comments to the last session. I found what Laura said and the work that BOSS have done is excellent. What they've achieved, for example, just one small thing I picked up on, where she talked of buying the canals and blocking them, and then providing an alternative livelihoods, and the people were then they didn't need to go back and break the canal blocking, and they didn't go and access. So you were stopping the opportunity of fires starting right by doing that. But it's this providing of alternative livelihoods. And so I was also really interested in Jenny's work on the sociological work, and I have a question. Sort of, Jenny, if you have some indication of what cost or what might help persuade, what kind of things that can be done to help persuade people, the local people, to change their practices, in particular either paying or giving an alternative livelihood. Two factors, either to just change the time they do the burning, to make it a month earlier or a month later. It's perhaps even better if it's earlier, where there is the surface is dry, but the peat may not get burnt below, but not burn in the middle of the dry season where it burns down into the peat. Or secondly, the option would be pay them enough so that they stop burning altogether. Do you have any indication of what the costs might be, or the alternative livelihoods? Or maybe some other speaker might answer those questions. Some sociological solution to provide alternative livelihood or pay the people for changing their practices. I'd like to get some comments from people on that, please. Thank you.
Yeah, thanks for that. So, I mean, I think Laura can definitely speak to this, because she's been working more closely, as she kind of mentioned, recently. And it seems like a lot of the more recent initiatives to get people to find alternatives is starting to work. I mean, there's been so many iterations of this in this particular site, right, over the last 20 years. And sometimes, you know, a lot of them have worked as long as there's funding, right? If the project ends, it's very tied to the sort of donor model. And then people, you know, they're frustrated, they can't continue the work for the project, and they go back to what they were doing, which is usually logging, or they really just need to use their farmland again. I mean, I could envision, you know, in an area like this where there is heavy community engagement in a lot of these villages, and they're used to working with, you know, with NGOs and civil society to sort of like deal with these issues, that there could be some sort of like, almost like what we're seeing with COVID, right? Like a tier system based on risk, right? Where at different stages of times, there's different risks, and then different, you know, restrictions are put in place. I think, you know, a blanket fire ban year round for all areas is not a great solution, right? So coming up, yeah, with some sort of very localized program where there was supervised burning in certain areas and people could continue to farm would certainly help. At least it would, I think, help prevent some of those the burn and run events, right? But there's an underlying problem too, where, you know, people in the area have for a very long time, I mean, far longer than even just 20 years, like they don't really make enough money, right, to support themselves, or they're not able to grow enough rice to even feed their family for the whole year on just the plots of land that they have, right? So they still need another source of income, right? And I, you know, the Dayak communities that I've interviewed, you know, they're also very, I think they really like to have a lot of different activities, right? Like they don't want to have just this like one thing that they do every day all year, which is why they've been in a lot of ways reluctant to just go work for an oil palm company, right? Like I think they like to alternate different activities and be out in the forest when they can. So, you know, I don't know that there's a year-round sort of option that would just solve all of those problems, but yeah, I mean, it sounds like Laura has kind of picked up the thread, right, of where we left off. Again, I haven't been there in the last, you know, couple of years to see the progress made, but yeah, I did have really strong kind of, you know, opinions about the fire ban, and I think that could be much more better implemented. But it would really take local engagement, and again, like, you know, awareness of the local fire conditions and the risks, right, of a particular year and a particular time of year. But I think it would be possible. A lot of the local leaders we talked to said they would be really happy to work with them, right, and work with local smallholders and supervise the controlled burning. But again, that's not a panacea, right? It doesn't solve all of their problems, but it might solve some of them.
Okay, thank you.
Yeah.
Okay, thank you so much, Pak Adam, and also Bu Jenny. I'm sure that we all are very glad and very happy that we can have a lot of share from our expert here, from Kate Esselman from UMCES, and also from Prof. Jenny from Cornell University, and also from Laura, Pak Asmadi, and Pak Sigit. We can have a lot of new findings here and a lot of lessons learned from the field. But I'm sorry, time is limiting us because I think it's already almost the midnight in the US and Mexico. So thank you very much for all of your participation, and thank you for sharing your experience, Pak Kate, and also Bu Jenny, and also Bu Laura, Pak Asmadi, and Pak Sigit. But before ending this session, I would like to ask for such like a concluding remarks from Mark and Pak Bambang. Mark, are you still there, Mark?
Yes, I'm here.
Okay. Please, some concluding remarks, Mark, from our
yes,
webinar today, before you are going to sleep.
Yeah. Well, I've been up since 5:30, so yeah. No, I mean, it's been an excellent evening. We've had, I mean, just tremendous presentations here. I've been really impressed. I'm thinking that some of you should probably present instead of me. I mean, I wish NASA had been here to hear all this actually, because I believe this is the kind of work that they're really interested in. Is it's not just funding and doing some papers. It's actually making a difference and getting applied and hopefully moving far beyond just this project. So I really appreciate all of you and everybody who's attending too. I've been very impressed. I mean, the number of people that are here and have stuck with us in the last two sessions, and I hope we've presented information that made it worth their time too. I would like to think so, but I really appreciate everybody who's presented here today and done a really good job of getting all these points across. I know I'm learning just watching this, so hope everybody else is too.
Okay, thank you, Mark, for your concluding remarks. Pak Bambang, please.
Okay, thank you, Indra. I think I am also very happy here because today is our second webinar, and then we are happy because all the experts here, all the speakers, have good feedback. This is the reason why then we run this webinars. So we would like to directly hear this from the expert or the people who are really concerned about the peat fires. So again, by the men of committee or also everybody who working on this, that at least for the second webinars, we thank very much for your participation. And then don't forget, we have another webinar. I think this is also quite important because this is linked with the issue on climate change. So we are also waiting for you all for the next, the last webinars, the third webinars that will be running soon. Thank you very much.
Okay, thank you, Pak Bambang, and thank you for all of your participation here, and especially for Kate. We are very sorry that there is some interference during your talk in the morning. We try to keep everything going smooth, but there is always something happened. Okay, I will give the time back to Bu Ati as the MC. Okay, please, Bu Ati.
Okay, thank you, Pak Indra, for being our moderator today, and to all the great speakers, thank you for sharing with us. So, ladies and gentlemen, we now come to the end of this event, the second International Webinar 2020. For the presentation material links and certificate will be sent to your email. So before you leave the meeting, for your information, as mentioned Pak Bambang, will be there will be the third international webinar on 15th of December next week by Team Fire and Smoke. Please mark the date and join with us. We already shared the link of registration on the chat room. On behalf of the host and committee, thank you all for making time to join us here today. And we look forward to seeing you at the next international webinar. Thank you and good morning. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Okay, thank you everybody. Terima kasih banyak.
Terima kasih banyak Bu Jenny.
See you. Thanks, Mark.
Thank you very much.
Jenny.
Okay.
Setting all this up as usual.
Boss, yes.
Okay.
Great how you were able to coordinate all this.
Have a great night, Mark, and also Kate.
Also Jenny, Kate.
Yeah, I got a bed with my name on it coming. So.
Okay. See you.
Thank you.
Bye. Yes. Cheers.
Okay.
Bye.
Thank you, Laura. Okay, thanks, Pak Adam. Alhamdulillah. Alhamdulillah. Sukses. Terima kasih Bu Ati, Mas Robi.
Sama Pak.